silence. We'll be starting our session very shortly. So please be seated and maintain silence. Hello. 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 ये अपने पास कर लो एकदम उनके सामने, वरना आवाज कम आ जाएगी। फिर तो आवाज बंद कर दें मैम। तो मेरी बात we are honored to have you. Hello. Hello, check. Everyone, please maintain silence. We'll be starting soon. A very good morning to one and all, respected dignitaries, invited guests, delegates, and faculty members. We welcome you all to the second day of our second International Symposium on Emerging Trends in Synthesis and Catalysis, ETSC 2023, organized by Department of Chemistry, Amity Institute of Applied Sciences, Amity University, Noida. We are honored to have with us Dr. Amit C. Kharakwal, Deputy Director, Amity Institute of Microbial Technology, Amity University, Noida, as session chair for this technical session 3 of second day. Dr. Suresh Sagadevan, Associate Professor of University of Malaysia, and Dr. Vinod Kumar Panusamy, Associate Professor, Kaohsiung Medical University, Taiwan, will be joining us online. Dr. Prasoon Kumar Roy, Scientist, DRDO, Dr. Bhanu Pratap Singh, Scientist, CSIR, NPL, New Delhi, Dr. G. Bharat, Professor, Department of Environmental Studies, Delhi Universities, as the eminent speakers of the session. Thank you all for joining us. I kindly request you all to please join us on the dais. Before we begin with this session, we extend a warm welcome by presenting saplings to our esteemed speakers. We request Dr. Amit C. Kharakwal to present the sapling to Dr. Prasoon Kumar Roy. Let me know when I have to. Now we request Dr. Deepshika to present the sapling to Dr. Amit C. Kharakwal. Thank you so much, ma'am. Now we are going to start our technical session 3 of Symposium ETSC 2023. And I would like to introduce our session chair, Dr. Amit C. Kharakwal.
Dr. Amit C. Kharakbal is a Deputy Director and Associate Professor at Amity Institute of Microbial Technology, Amity University, Noida. He holds a PhD in Conservation of Podophyllum Hexandrum royale and Masters in Environmental Botany. With the experience in leading research organizations, he has researched various topics in agricultural biotechnology, including plant cell, tissue, hairy root culture, plant genetic manipulation, germplasm characterization, and seed biology. His current research areas focus on R&D, formulation, training and demonstration of novel biofertilizers for sustainable agriculture. He is also working on developing and commercialization novel plant promoting fungal root endotypes. He has published one edited book, 51 papers, and he has around 19 patents, including a US patent. Now, I would like to invite Dr. Amit Sikharakwal sir to please give us the permission to start the technical session 3. Kindly start. Thank you so much, sir.
Uh, it's my honor to introduce the first speaker for our session, Dr. Vinod Kumar Panusamy, who will be joining us online. Dr. Vinod Kumar Panusamy is an associate professor and research faculty at the Department of Medicinal and Applied Chemistry and Research Center for Environmental Medicine at Kaohsiung Medical University, Taiwan. Dr. Kumar completed his PhD in analytical chemistry at National Chongqing University in Taiwan. His research and teaching interests include nanomaterials, sample preparations, green analytical methodologies, mass spectrometric analysis, and method developments for clinical, food, drugs, and environmental analysis. He has authored and co-authored over 160 SCI publications, 2 books, and presented in 150 international and national conferences, including 50 invited keynote lectures. He is also an editorial board member of several chemistry journals and has peer reviewed for several reputed scientific journals in the field of analytical chemistry, environmental sciences, nanomaterials, and green energy. We welcome you, sir.
Thank you so much. Is that audible and my slides are clear? Can anyone reply to me? Is my voice is clear?
Yes, sir, it's clear. Thank you.
Okay, great. Oh, yeah, great. Thank you so much. Yeah. So first of all, I would like to thank Professor Dr. Sunita Ratan, the chairperson of this conference, and for our kind invitation to participate in this conference. I'm really glad to have this great invitation. And also, I thank the session chair for his kind introduction about me. Before going to my talk, so I'm going to talk about a little bit about Kaohsiung Medical University, Taiwan. So since Amity University and Kaohsiung Medical University is almost partners for, I think, more than 6 years. And we already have a lot of exchange students from Amity. And we also had a lot of doctoral students who came to join as a PhD students in KMU. So we have a long connection between Amity University and KMU University. But maybe I'm going to give some more introduction about Kaohsiung Medical University today as well, because I can see there are a lot of new students here. And after that, I'm going to introduce about my research. So particularly today, I'm going to talk about my research topic, which is about the green analytical technologies. Like mostly, we use a lot of analytical technologies, particularly in modern days, people are, changing towards to green-based analytical technologies and using that to produce, the rapid diagnostics or rapid testings so that like we can apply to various applications. So today I'm just going to focus on environmental applications. So here is my email ID and my research group website. So if you want to know more about my research, please just visit my website as well as my email ID if you want to have more questions. So here is, I think like maybe some people, they might be not aware about where is Taiwan. So Taiwan is just very close to Hong Kong. So if you know Hong Kong, and it's just under below to the Japan and Korea. So actually, when you consider the location, it's almost like, starting from, if you draw a line from Delhi, you can able to, you can able to, the almost the same equator in towards Delhi. So almost like the weather, temperature, everything is almost same. And you can able to see here in this figure, like Kaohsiung is the second largest city in Taiwan. So the capital city is in the north, which is the Taipei city. And Kaohsiung city is the second largest, which is located in the south part of Taiwan. So here you can able to see the view of Kaohsiung. So actually Kaohsiung is one of the hottest city, which we can say, like, it's the largest harbor city, and you can able to see the harbor view. And from here, we can able to see the Kaohsiung Medical University is located in the heart of the city, actually. So it's more convenient and vibrant place for studying, living, and all these things. So it's the Kaohsiung city. And here we can able to see the Kaohsiung Medical University campus. So there's a playground we have, and all the buildings around are the Kaohsiung Medical University. So most of the research buildings here. So at present, I am talking to you all from this building at the 11th floor. Yeah. So and talking about Kaohsiung Medical University, it's not only the university. Actually, it's associated with a lot of hospitals. So we have 5 big hospitals with advanced medical treatment technologies and also medical research. So here are the major support for our university research. So that's why our most of the departments we work very close to medical based research. So coming to the chemistry department, so actually our department is not just a general chemistry department. Actually, our department is specialized towards medicinal chemistry and as well as applied chemistry. So since it's a medical university, so all the chemistry research be mostly, very close to the medical research. So that's why we have a logo of like a great place where chemistry meets medicine. So this is our department's logo. So our department have excellent facilities. Like we have a lot of NMRs, a lot of high-tech mass spectrometers, and for nanomaterials, we have like all kind of characterization facilities such as like SEMT, MXRD, all these high-tech equipment. So it's a well-equipped department for all kind of chemistry research, including organic, inorganic materials, as well as analytical chemistry, and also the bioorganic chemistry, which is almost close to medicinal chemistry. So we do have a lot of programs, particularly we have some joint PhD programs with some Taiwanese companies, particularly recently a Taiwanese company called China Synthetic Rubber Corporation. They invested more than 1,000 crores of investment in Gujarat, and particularly they produce rubber materials and rubber-based products. So they had a MOU with our department to have a joint PhD program. So it's actually like, the students who like to join this PhD program and they get the PhD in KMU and they directly appointed to work as like a supervisor, manager, director in the Gujarat plant in the R&D sector or in the production sector. So it's completely funded project, which is located in, which is actually going to work in Gujarat. Apart from this, we also have a lot of other scholarship for PhD programs, and also we had a lot of internship programs, particularly the internship programs called as TEEP internship programs. So it's also fully funded. So if the students are interested towards internship program on various field of chemistry, like you can also approach to the professors in chemistry department in KMU. So mostly master level, PhD level will get more preference, and the outstanding bachelor level students also get preference to get this excellent opportunity to join and explore Kaohsiung Medical University. So these are some of the photos of the previous students. I think here also you can able to see some of the Amity University students in this exchange photos. Okay, so yeah, so those are my introduction about the university and also about the department. So and now I'm moving on to my research topic, because I think the speech timing is very limited, 30 minutes. So I'm going to give a very simple overview of my research. I'm not going to very detailed. So if you have any detailed questions, please feel free to email me. to discuss more about if you have any questions. And talking about my research group name itself is called as a Nano and Green Analytical Technology Lab. So we have two research groups. One is focusing more on green analytical technology, and another group focusing on nano analytical technology. So in the first group, mostly it's about the chromatography and mass spectrometry analysis for identifying the toxins, identifying the contaminants, and identifying the metabolites or biomarkers or biometabolites. So it's more about analytical stuff. Particularly, it's including all kind of samples, including starting from environmental samples to food sample to biological samples. So since we have the high-tech facility of chromatographic and mass spectrometrics facility, so among in this group, like the major thing we are working on the development of new sample preparation techniques, which mostly working towards the automated sample preparation technique, because the major challenging in analysis is all about the manual process of making the samples and then to do the analysis. So it's all time consuming and expensive process. So we are working on the development of automated sample preparation techniques to connect to automated HPLC, to connect it to automated GC and mass spectrometer. So these are the major research that we are focusing here. So in this research, we do have all kind of tandem mass spectrometers, HPLCs, GCs, even we do some sensor work. So we do have a lot of cyclic voltammeters. So here you can able to see all kind of HRMS and normal based mass spectrometers. So these are the facilities in my lab. And the second group that we are working on the nano and micro materials technology. So here we mostly focusing on green materials, which means like the material which is non-toxic. And during the synthesis process, we don't want to use any toxic chemical agents or something. So we want to produce this material as a pure green based material. So most of the material that we work are bio-based material, biomaterials or bio-based nanomaterials, or is non-toxic, and and other related to those materials have different application towards environmental side, sensor side, even supercapacitor energy side. And we also work on green energy based works, particularly on the conversion of biomass into biofuels or biogases, even the value added products from biofuel or from the biomass. So these are the works that we are working in the second research group. So almost we are working more multidisciplinary level, but the core focus in our research is all about analytical chemistry. So these are the facilities that we have for the nanomaterial synthesis. And this is my current group strength. So you can able to see it's almost full of Indian students. Like we have a lot of Indian students and other foreigner students from different countries such as Malaysia, Vietnam, and from also some students from European, and also the local Taiwanese students are here. So these are the groups at present. So since in the last 2 years, I also studied the world's top 2% scientist ranking based on the citations. And currently, I'm also acting as several journal services, such as like associate editor and special issue editing in different journals. So these are the things that we're working. So the major focus in our green analytical technology group is all about to identify the emerging pollutants. So in our daily life, the new products are coming, new chemicals are emerging, and then it's coming to the daily life, and we are exposing, and we don't know what we are exposing. And these are the chemicals they're introducing, and then we need to make sure the toxicity of the emerging compounds, and we need to know the exposure level of those compounds. That's a very important thing. So particularly in recent days, the personal care products and pharmaceutical products and household products are really emerging. Like a lot of innovative products are coming in our daily life, and we are using those products and we are exposing into those chemicals. So that's why slowly another research called as exposome research, the exposome, which we mainly talking about the environmental pollutants or environmentally occurring compounds and how we expose to them. So we usually expose into two ways. One is from the atmosphere, from through air, and another one is through consumption. So in the consumption of food, consumption of water. So all this contains a lot of chemicals. Finally, all this chemical get into the body and particularly get into the our human system, into the cell, and getting into the cell, and finally most of the compounds, it have a very good affinity with the DNA or RNA, and finally these compounds, like it have a huge effect into the human body, because it's going to have a DNA adducts or maybe RNA adducts or the protein adducts, and this going to change the cell metabolism, and it's going to be, there are a lot of chance to become the cancer cell. So this is the way that the recent generation is going to have the huge effect on the emerging environmental pollution. So for this particular purpose, we need to identify the emerging pollutant, we need to identify the toxicity, and we need to identify the human's exposure level towards those compounds. So for all this purpose, we need to know the analysis process, because without analysis, we don't know, like, what is the contaminant is there and what is the concentration is there, and without analysis we don't know how much we expose. So we need to analyze our urine sample, we need to analyze our blood sample to make sure the exposure level. So all this thing, we need a high tech analytical technologies. So analytical technology, although we have expensive instruments such as like mass spectrometers, such as like LC MSMS or LC high resolution MS or GC high resolution MS, it's all very high tech expensive instrument, but the instrument is not alone to be used for the analysis process. We also need to do the sample preparation process. The sample preparation process is one of the important process before going to do the mass spec analysis or the chromatography analysis. So this is a place like where you need to isolate the target analytical compound and to remove the unwanted material. So that's, we call it as matrix components removal, because this thing will give you the huge interference towards your analysis. So when the matrix interference happens in your analysis, you cannot get an accurate result. So for this particular purpose, like we are developing, we mainly working on sample preparation technology, and particularly so far most of the sample preparation is a manual process, which takes almost, for each sample preparation you need to take almost 1 hour to 3 hours of time, and also manual process. So we are working on the automated sample preparation, and also very rapid, and also making into the low cost process. So as we know that for clinical diagnostic or food toxins identification or environmental identifications, all we need to know is, like, we need to get our test report as soon with a low cost. That is the major challenging process in the analytical chemistry process. So our group, we are mainly working on to reduce the price of the analytical cost through making automation and making it rapid and making more sensitive. That is the main main process that we are working on. So all this process, as we know, in our daily life, we drink water, we eat foods, and we take a lot of cosmetic personal care products, and all contain several toxins, adulterants, or even like illegal ingredients. All these things are there, which is finally exposed to our human body. So we need to make sure how much we expose. So mostly for this exposure identification, we need to directly can able to analyze the exposed compounds, or sometimes it changes the metabolism and it's going to release some biometabolites, or it's going to release some biomarkers. So we can able to identify these compounds to make sure how much we are exposed. So if we know the exposure level, then we can able to predict the possible human effects. Maybe most of the things is converted into cancers. So it's kind of a cancer diagnostic process to help the humans. So in our lab, we analyze all these things, like to identify the new emerging components, and we also do clinical and biological analysis to identify the exposure level to protect the humans, particularly there. So this is the main human biomonitoring project that we are working. So in the human biomonitoring, we need to collect the samples from the patient exposed people or to the normal volunteers. So mostly we working on the samples like urine sample, saliva sample, breast milk, and even the breath sample and the nail samples. Okay. And so these are the human samples that we take, and we use to identify the different exposures, because the air pollution, particularly talking about India, the air pollution is a very serious pollution. And the second, water pollution, soil pollution is also one of the leading thing in India. So we need to know like what are the contaminants there and how much we are exposing and how much we are going to, going to have a human health. It is an important thing to understand. So this is because, it's directly involving into the human, the period of, how long we are going to live. So as we know that, our lifespan is, getting decreased, like, people used to live like 90 years, 100 years, but now people, the average lifespan is reduced to 70. So even, all this pollution, it's still going to increase. So it's going to be less. So the human life is going to be, lesser than less. So for this particular purpose, we need to know the exposure level and also need to identify the toxic products. So for this important thing, we are working towards this task in our research group. So hereafter, I'm going to discuss some of the research outputs that we have. So recently, we had a paper. We developed a sample preparation technique using a cellulose paper. So cellulose paper is one of the cheapest material, but we use this material to use some other nanomaterials and working as like a solid phase extraction to analyze the para-hydroxybenzenoids, which is simply called as the parabens. The parabens is very commonly available in most of the in food products, cosmetic products. So these things finally end up into the environmental system. So once it's ended into environmental system, it's a cyclic process because water is life. So if it's get into the water, it's everywhere. It's into the animals, it's into the aquatic animals, into the normal animals, and to the humans. It's a cycle. So identifying the water analysis and particularly identify the pollutants in the drinking waters is one of the important essential factors. So for this purpose, we do a lot of water analysis to identify the toxins. So for particular this purpose, we need to make the technology more low cost, more efficient, and more sensitive. So for this purpose, we develop the low cost process to identify all these things. So as we know, the parabens, you can see from all the food products, so almost we consume every day, almost you can see any one of the paraben you can able to see in these products. So most of our Indian processed food, they added a lot of paraben products. So the paraben is actually the endocrines descripting chemical, so it's toxic and it's banned in the Western countries like US and Europe. And still most of the Asian countries, the regulation is not clear. So it's going to the contaminant to the water, and the water, so it's become a cycle. So for this particular purpose, we developed we call it as a bio-based, material-based sample preparation process. So previously, people used several different kind of technique to remove this particular toxins, the parabens, but although it's very expensive process, time consuming process. So for this particular purpose, like we developed a microfluidic paper, which is using the cellulose and modified with the carbon nanofiber. And because carbon nanofiber is it's also very low cost material, we have a very good absorption ability. So we use these two combination to create the material. So for this particular process, we take the cellulose paper and nanofibers and then activated and then use the polymers and then to make it as a the unique substrate to absorb the parabens. So these are the mechanisms here. So you can able to visit this paper. So you can able to see the modifications of the cellulose paper along with the nanofibers and then to the polymer. So we get a very clear efficient to get absorption. So for this particular purpose, instead of going to the mass spectrometer, because mass spectrometer is a huge expensive instrument, so we can simply use HPLC PDA or HPLC UV, so which is a low cost instrument. So using our developed sample preparation and along with the HPLC UV, you can able to get a very low cost analysis of this particular thing. So this is the material that we processed and the final composite. So these are the characterization data, so that I don't want to go into the very detailed thing in this characterization. So you can able to see from this particular method development, you can have a very sensitive analysis. You can able to see 0.2 ppb So it's a very low sensitive, it's almost lesser than the mass spectrometric analysis. So for this particular analysis, usually people use the LCMS to analysis. So for LCMS, it's almost 2 to 3 crore of instrument, but HPLC is just only 20 lakhs instrument. So it's almost tenfold of cost difference you can able to have, and also very rapid methodology. So we apply this method near to the our KMU University. So near to our university, there is a river called, it's a very famous river called Lao River, and this is another lake called Chengqing Lake. So we used to monitor this kind of nearby water resources to check the contaminants. We also found a little bit of paraben contaminations in the domestic sewage water, because of course you're going to use a lot of personal care products, so you still can able to see all these things. So this technology is like the real time is also we are able to detect. So this methodology, when compared to all other methods, it's very sensitive and uh, uh, very low cost and very affordable technique, which we can able to apply for the analysis of parabens in the water. And we also working on a lot of food-based thing, particularly egg is one of the daily, without, and almost most of the countries, egg is the prayer breakfast. So almost every day people used to eat egg. But recently there are a lot of contaminants in the egg. Particularly there is the insecticide or herbicide called as a fipronil, and there are some of the metabolites out there. So usually this thing, it's going to be in Asian markets still there are people are using this thing to for the thing. So there is a lot of contamination in the egg sample and also in the soil sample. So recently we also developed the methodology, which is a green methodology. We call it as a FAPEX methodology, which is the fast pesticide extraction technology, which we developed. So I already mentioned we do a lot of automation stuff. So we developed this technology. We take the egg sample and then do the extraction. And after the extraction, we need to do the cleanup process. We're using the automated technique and directly inject the LC-MSMS. We call it as a UHPLC, which is ultra high pressure liquid chromatography tandem mass spectrometer. So expensive instrument, because this protocol we are promoting towards to the FDA in Taiwan, so that they can use this methodology to protect the local people here. So this is the low cost in sense of when compared to the previous method. So previously the government methodology is still expensive, so we make it into the low cost methodology and more sensitive and more accurate. And recently there is another compound, we call it as hyaluronate, sodium hyaluronate, which is commonly used. It's actually it's a good it's an important component in our human skin. So most of the skincare products and the personal care products, they're going to have this kind of ingredient, and particularly the ingredient, the purity level is have a huge effects on the product quality. So for this particular purpose, we developed a very rapid technology method to analyze the hyaluronic acid using this particular technology. And for this particular technology, we use the detector called ELSD, which is a light scattering detector. Okay, so evaporative light scattering detector is the another detector which can able to use to detect this compound in a very sensitive way. So this is another thing. Excuse me. So again. Yeah. So this is another thing. So, and also we do work on a lot of other environmental pollutant analysis, particularly triclosan and tricarbene. It's a very common pollutant in the environmental water, in particular in Asia. So since most of our toothpaste and mouthwash and most of the personal care products have this particular toxins, and actually it's an antibacterial product, agents. So it's very commonly occur in the environmental water. So for this particular process, we also developed a semi-automated protocol using HPLC. So we can also use this particular simple methodology to able to analyze all these things. So this is another technology we developed. And particularly in Taiwan and China, there is a habit of eating the betel nuts. Similar like India, but in India, like they don't eat the fresh betel nuts. But in India, we used to eat a dry betel nut sample, and mostly since like in Taiwan, like they use like this kind of fresh betel nuts, and mostly for the prolonged consumption, it's going to have a oral cancer, the mouth cancer. So particular this process, we need to understand how much they exposed, and we also need to know which kind of toxic compound it creates the oral cancer. So we also have made a detailed study into this particular thing to protect the humans here. So we identify a lot of components using our technology, and we analyzed urine sample, saliva sample, and also tissue samples to detect the toxic components, and then to identify the exposure level, so to protect how much exposure thing. And so mostly this kind of things you can able to see it's a Indian style of eating the betel nuts. But although this kind of thing, like there is a component called nitrosocoalinine, which is more carcinogenic for creating the cancer. So particularly it's a combination like the leaf and the betel nut, and along with the calcium hydroxide. So here the calcium hydroxide makes a huge difference when you're chewing this one, because the alkaline condition make it release of the particular alkaloids to create the concentration is going to be high, and then it's going to create a huge interference. So for this thing, we studied a lot of human physiological study and also the analytical study to
So,
make
Dr.
yeah,
Vinod,
yeah,
can
yeah,
you conclude now?
yeah, sure, yeah. So these are the
Yeah,
human
can you
based
conclude also within 5 minutes?
yeah, sure, no problem, yeah. So we do
Thank
a
you.
lot of biomonitoring stuffs like something like this. So apart from this, during the COVID also, there is a new drug has been evolved, which is called a Ramstivir. And the Ramstivir drug, we also made a therapeutic drug monitoring development, and then we applied for the COVID patients. And we also monitoring, during the sports person, they used to have the doping substance, particularly even including the nicotine to other kind of doping substance. So we do monitor the sports person's urine to see their doping substance in a very quick and advanced way using the automated techniques. And also, we also check a lot of cardiologic based things, particularly, in India, the cardiology risk is getting higher and higher because of the lack of omega fatty acids in our human diet. So we also monitor in the human blood the concentration of omega-3 and omega-4, omega-6 fatty acids, and how they influence. So there's a lot of analytical methodologies we develop to protect and to diagnose the humans. And we also work on a lot of sensors, electrochemical sensors, to detect most of the heavy metals in the contamination, and other kind of sensors for different biosensors for analyzing various environmental toxins or biomarkers, all these kind of things. So I'm going to skip all these things, and just going to give you just you can know what are the things that we are working in our lab. So I just give the glimpse. So if you need more details, you can go through my profile, and we can also discuss in the email. So I'm going to directly going to the conclusion part. Okay, yeah. So these are the things happen only through collaboration. So these are my local collaborations in US, in India, and most other countries. So these are the collaborations, and I do thank for most of the financial supports from the various funding agencies. And in conclusion, I would like to say in our research group, like we mostly focusing on more major things on the analytical chemistry, particularly to develop the green analytical technologies. And also the another group, we develop a lot of innovative nanomaterials to apply towards to making novel electrochemical sensors, and also photocatalysis. All these things are we are going to produce. Okay, so that's all about my talks. Thanks for your listening. Thank you so much. Yeah.
Thank you very much for your inspiring talk.
Yeah.
Talking about sensitive technology for environmental monitoring, so very appropriate topic. We are, all having exposure to a lot of environmental hazards, and that too at a very, low level, but it biomagnifies and creates a problem in the entire ecosystem.
Yes.
So many congratulations. So any questions from the audience or faculty staff? Any questions from the students? So thank you, Dr. Vinod, once again for your
Thank you so
talk.
much.
Very
Yeah,
inspiring talk. Thank you.
Thank you so much. Thank you so much. Yeah. Thank you.
Thank you, sir, for your talk. Before we continue with the session, we would like to welcome Dr. G. Bharat. Sir, we welcome you on the dais.
Good morning, sir.
We request Dr. Amit C. Kharakwal to present the sapling to Dr. G. Bharat.
Thank you so much, sir. Now, I would like to introduce Dr. Suresh Sagadevan. Dr. Suresh Sagadevan, currently an associate professor and head for international affairs at Nanotechnology and Catalysis Research Center, NanoCat, University of Malaysia, is a renowned researcher with over 350 publications in top tier journals and scopus referred internationally. His research interests span a wide range of fields, including nanofabrication, functional materials, graphene, polymeric nanocomposites, and biosensor applications. In addition, he has authored 12 international book series and 42 book chapters. Dr. Sagadevan is a fellow of Royal Society of Chemistry and has been recognized as the one of top 2% scientists in the world since 2020. He is also a member of various professional bodies at the national and international level and has served as a guest editor for several reputed ISI journals. Over to you, sir.
Thank you. Can you see my presentation?
Yes, sir. Yes, sir.
Thank you very much for your kind introduction. I'm very happy to join this international symposium on emerging trends in synthesis and catalysis organized by Department of Chemistry, Amity Institute of Applied Science, Amity University, Noida, India. First, I would like to congratulate the organizing team members for the excellent arrangement for this international symposium. I would like to recognize and respect all professors, research scholars, students, and the participants from the various institutions to this occasion. I hope the participants have benefited by attending this all section of this following 2 days of this symposium. Before start my lectures, just I would like to present about my university and about my center, what the researches are we are doing on it. The Malaysia is a beautiful tourist spot, tourist place. If any opportunity, you must visit in Malaysia. You can see the notable places in Malaysia. The one is a Twin Tower, and another one is a big statue, Badmurkha statue, Bachkev, and another Chinese temple here. And then there's a Longavi, is very good seashore place, very beautiful view. If you have any opportunity, you may visit us this place in the Malaysia. And then about our university, 2020 and until 2023, so our university is a world ranking. The QS ranking is 17th place. We are the number one university in Malaysia. QS ranking is 17th. So we have a lot of centers and we have international faculty members. and as well as we have many schools, electrical, mechanical, and also we have the medical. Medical is very good in our campus industry. And then where we are in that inside of university campus, the University of Malaya is located in this capital city of Malaysia, which is the Kuala Lumpur. You can see this place here. This Kuala Lumpur is very close to for this university is located to KL, and we have very close to as Singapore, Thailand, Indonesia. So the Asian country is very close to us. And also you can look at here. This is our center is located in Institute of Advanced Studies, IPS building. We are in that. This is our campus. Our center is located here, and we have the sophisticated facilities in our center. Our center was established in the year of 2001. Mostly past more than of 1 decade, and then we are doing the research on following areas: energy catalysis, biomass catalysis, and environmental catalysis and catalysis. If you are interested, you can see that our research area, what we are doing in our centers, we are designing this material, and also we are working on the smart material, and we concentrated for chemical catalysis, energy catalysis, environmental catalysis. So we are offering for a master program, a master of philosophy, and then PhD program. So those who are interested to study here, we are offering for scholarship, international scholarship from our university. This information for especially student community, those who are very much interested to study in Malaysia, especially for our university. You can see that our university website, and you can find the information, the scholarship information. Every year they will offer these student scholarship, and you can apply. Then you can study. You can do for master program and as well as PhD program here. So my talk, I'm going to present. Actually, my presentation is very simple because the symposium, which means that the students gathering here. So I prepared for simple talk, not that much advanced level material or advanced level information I cannot give. Just one simple things. The first introduction and objectives of my talk, and then what about that experimental for depletion of the sample, result and discussion. Finally, conclusion. So that introduction, I'm going to give a talk about the photocatalyst because the previous talk he delivered for this environmental remediations. I hope that everyone is because he given that enormous of information to us, and then he given that more information and more insights to us. So my talk should be related with photocatalysis, because this work is done by my student, so we done using by the photocatalyst. The photocatalytic degradations has emerged as a promising treatment for process. Usually, the rapid development of photocatalyst field, the photocatalyst have received increasing this attention because of the important role in this environmental pollutions and energy crisis. So you see, modern science and technology have made life and the human beings very comfortable. But at the same time, they have caused the demand for energy to increase. So these issues have prompted for the research for green and sustainable alternative energy conversion, as well as the energy storage devices. So in that view, we concentrated on graphene material with a metal oxide, graphene nanocomposite, graphite with metal oxide. Derivatives have received this extensive attention of this scientific community to resolve the energy renovation and as well as the environmental pollutions. So the graphene and its derivative have extraordinary properties, as you know, that because the reason is the unique atom thick and the 2D structure, high surface area, high conductivity, and high electrical mobility. Many properties like anti-corrosion, photosensitivity, and also the excellent chemical stability. So the efficient of photocatalyst. As you know that everyone is know these basic things because when you're converting this size of this material from bulk to nano, you can see that how the properties are enhanced. You look at here, the surface area is increased so that most of the nanocomposite material can be used for 3 important areas: energy, environment, and biomedical applications. Because of you can see that here the electron band gap is also increases, so that it is, for example, of solar cell and photovoltaic activity, and electric property for using for nanofield coatings, and magnetic properties it is using for the magnetic separation. And as well as my main properties, the important properties, catalytic, the better catalytic efficiency, and electrical properties. Usually, as we know that we cannot, use any metal oxide for this device fabrication. But now we can use for metal oxide, because when you're reducing the size, the energy bandwidth is increases. It is comparable with the semiconductor range. So as well as you can see that mechanical properties, they improve the hardness and toughness of this metals and alloy. And optical, the spectral shift of optical absorption and fluorescence, and magnetic, you can see that increase the magnetic coercivity and the supermagnetic behavior. So the potential applications now, many researchers, they developed a lot of products in this different applications, and they made a lot of products like transistor, sensor, lithium-ion battery, energy storage, solar cell, catalytic photocatalytic process, and then non-volatile memory devices, paneling devices, drug delivery, bioceramic, and antibacterial coatings. You can look at here; these are all already, the people are developed and they used for many applications for using, based on this nanocomposite material. My talk: why we choose for graphene carbonate based nanocomposite. Usually, that nanohybrids have gained, consideration due to their potential functionality and tailor-made the application. So the health and environmental influence of graphene-based material should be carefully assessed in advance for the prospect of application. So taking this advantage, the excellent properties of this material, many groups have widely researched its capability as a photocatalyst. That's why we have chosen for this graphene carbonate nitrate, and we mixed, we added with that two metal oxide. One is a zinc oxide and another one is a cuprous oxide. So nanocomposite. Why the reason is, there are the important things is a simple preparation method, not that much complicated. Very easily you can prepare it. The cost effect is, low cost. The stability is very excellent. And then there are two important, our aim of this task is high catalytic activity and as well as high photocatalytic. So this objective of my talk is to synthesize of two metal oxide with graphene carbonate, the composites using the simple chemical co-precipitation route and solvothermal method. To study this physical chemical characterization about XRD, FTIR, UV, SEM, TEM, and AFM. And finally, we studied for this photocatalytic applications. As I told you that why we choose for the graphene carbonate, this is a motivation of this our talk, but why we choose for the graphene carbonate, the reason is high surface area. This is very important. So when you look for these catalytic applications, you need to for large surface area. So it is enhanced high surface area and as well as the fast charge transfer. And another important thing is whether it's the toxicity or non-toxicity. But this graphene carbonate is a non-toxicity and easy to very affordable price, is a low cost. And this material is biocompatible. The first I'm going to discuss about the graphene carbonate with the zinc oxide nanocomposite to enhance the photocatalytic activity under this visible light. So how to prepare this? We prepare for zinc oxide nanoparticle and then graphene carbonate and then this composite. The first we prepare this zinc acetate, zinc oxide by using the precursor is zinc acetate mixed with water, and then we added the sodium hydroxide solution as a tapping agent. After we got the precipitation, then we can go to the filtration and calcination. Finally, we got that zinc oxide. And then we commercially, graphene carbonate, then mixed with by ball milling. Then we added washed with ethanol and concentration. Finally, we got that graphene carbonate zinc oxide composite. This is very simple procedure. Anyone you can do it, especially for master students. You may try with many metal oxides and then this graphene carbonate, and you can do your project. And then we done for this X-ray diffraction analysis. And this might talk particularly for the student community. What information we can find out from this XRD, FTIR, and UV and SEM and TEM. Just I'm going to tell you that information. From this XRD, we have to confirm that the structural properties, like the crystal structure and crystal phase, and then whether it is size. From this, you can see the XRT pattern of three material. The first one is representing the graphene carbon nitride. If the graphene carbon nitride is amorphous nature, you can see that we can got that amorphous nature and carbon. And then only one peaks are we obtained, which is confirmed 002 peak, which is confirmed by the graphene carbon nitride. Then zinc oxide, you can see here this peak indexed by 110010, which is represented by the zinc oxide. And also from this peak, if you see that the peak is very high, like high intensity and also sharp peak, which means that the material have the crystalline nature. So we confirm that first it's a graphene carbon nitride and B is the zinc oxide. Now you can look at this composite X-ray pattern. You can see that the small the peak is present, that one is 002, which means that in the composites the graphite is present here, right? This from this confirm, from this XRT, we should confirm that these peaks are present, and also all peaks are well matched with that. Zinc oxide peak well matched with that composite. So which means that this is a confirm the successful formation of this composite, and as well as we can say that how to purity of the sample. The purity of the sample based on that peak intensity. You can see that we have got that high intensity peaks, which means that the sample have the high purity and as well as high crystalline nature. So from this XRT, we observe that we confirm this. The zinc oxide is a crystal structure, and as well as the composite peaks is well matched with this zinc oxide. We confirm that through this X-ray diffraction, the successful formation of this composite. And next we perform this FTIR analysis. This comparison of FTIR analysis, you can look at here. When you mix it with that graphene carbonate and zinc oxide, there are two, the lower frequency region, which usually we can consider as a metal oxygen switching of vibration. You can see that how, where the zinc oxide is present. The zinc oxide peaks are represented by 5 to centimeters in 1. This is a stitching of vibration. The same peaks observed in that composite. You can look at here, this C is a composite, which means that and as well as other peaks, this 3362 is the water is present OH stitching of vibration. And then how to confirm this, carbon and with the nitrogen switching of vibration. The carbon nitrogen switching vibrations in the range of 1600. Especially we can say that the carbon and nitrogen switching of vibration around 1600. 640. This peaks which is confirmed that carbon nitrate. So from this FTIR analysis, we confirm this again. These materials are present and all the elemental groups are present in this composite, which is confirmed by FTIR analysis. Next, we have performed this UV analysis, the optical properties and optical studies. From this UV studies, we observe that the maximum of absorptions. You will look at here. This all the three compound. One is a graphene carbon nitride. It is A is a red. It is how much it is 480 nanometer. It is all or it's a visible region. Visible region. If you want to look for this photocatalytic application, that absorption should be in the range of visible. Then you can get the good catalytic activity. Like this, the graphene carbon 480 nanometer and the composite. The composite is a B, is a black one. Is you can look at here. This how much is this? Firstly 471. So all of this is very good, visible range. And alone, look at this metal oxide, the zinc oxide, which is a C. C is a blue, and then it is a 380 nanometer. So from this UV absorptions, we can confirm that this material have the visible region, and which is have high photocatalytic activity, and as well as we calculate this band gap value for this three compounds, and then the band gap value of this graphite carbon nitride. This is a is a graphene carbon nitride, which is the band gap value is a 2.35 electron volt. And C is a metal oxide, zinc oxide, the band gap value is 3.06. But when you look at that composite, it's a 2.47 electron. So band gap also, it is a it is range of semiconducting. It's good for this catalytic activity for this band gap value. And then we confirm this TEM analysis. You can see that how do you confirm this morphology of this material, free material, you can look at that very, clearly you can understand that usually the graphite is a sheet-like morphology, which is confirmed by this TEM analysis. You can look at here, you can see that here the sheet-like morphologies we completely absorbed from this figure A, and figure B is zinc oxide TEM image. You can see that this is a exogenous, structure. You can easily find out, right, what's a structure from this B. And also you can see that C is a composite, how it is completely wrapped with that graphene sheet. You look at here is the inside the sheet that zinc oxides are present. So which is also confirmed, and also the evidence for the successful formation of this composite completely is wrapped with that zinc oxide. And also we are done with that AFM analysis. You look at the topographic image of three compound. One A is represented by the graphene carbonated, which is like sheet-like morphology. You can easily see from this graph, from this topographic image, you can see in that, and as well as you can see that here. B is a rod-like structure. This is metal oxide, zinc oxide, and C is a composite. You see how that zinc oxide is incorporated and wrapped with that sheet, and you can look at here the rod shapes zinc oxide. So this is a very good agreement with that TEM analysis. This is a composite formulation. Now we perform this photocatalytic activity. The photocatalytic activity, we done that. Four we are using for 4 dyes, the organic, industrial dyes, malachitin green, rhodamine B, ancora red, and then red ink. So the photocatalytic efficiency of the prepare the sample, we used for aqueous medium. The photocatalytic reactions over a certain period of the time interval is 0 to 45 minutes. From the figure, you can clearly understand that the absorptions are decreases with increasing the time from that figure, and as well as you can see the table, the values are mentioned that. From the analysis, from the table, you can see that you can observe that the composite has an activity against all the dyes, all the dyes, and solution test the activities decreased with increasing the time period. So, which means that the losing of a number of active catalytic sites. In addition, that you can look at here all the 4 dyes. You can see that the red ink shows that high absorption when compared with other dyes like malachitin green, rhodamine B, and the ancora red. So from this UV, from this UV spectra, just we you can see that this how the dyes are degraded, and then we have to calculate that photocatalytic degradation efficiency versus time. You can see this graph. You can clearly understand we used for different dyes. Which one is showing for high efficiency, high dye degraded? From this graph, you can see that malachitin green is a black one showing for 97%, 97.24%, followed by rhodamine B is 82.37, and then ancora red is 70.05, and then 46.99% for red ink. And as well as we have plotted the graph between the rate of degradation constant and as well as that time. You can see that this one different, in absence of light, there is no changes, but when you see that visible light, you observe that significant changes in that photocatalytic effect. And then this one is first order kinetic studies. We calculate this, R squared value. From this R squared value, we're showing for 0.986. This range should be is a high catalytic activity. This is a general mechanism of how the electron and holes when light energies are applied. This is a mechanism. So next, I'm going to present for this next material is graphene carbonated with copper oxide. This one we done with the solvothermal method, graphene carbonated, and so 100 ml of ethanol and sonicated for 50 minutes. You can see that the haploidal shape, beautiful morphology of copper oxide, and then we were done for this. These two solutions were taken in that autoclave, and then for 180 degrees Celsius, heated for 180 degrees Celsius for 12 hours. Finally, we got that this composite. After this composite, we done this, photocatalytic activity for methylene blue for different dyes, rhodamine B, thiamine blue, and blue ink. then we followed by the physical chemical characterization, UV, XRD, FSM. Dear students, you look at here, this is only I presented because the different form. This is a composite X-ray diffraction part, and you can see that how many peaks are present. You know, the mixing of composite means the metal oxide and as well as the graphene carbonate. The two peaks are present together. You look at here, this block dot is a carbon graphene carbonate. You can see that this one 110 and 002 plane, which is indicated by the graphene carbonate, and then a cuprous oxide, which is represented by the prominent peak of 11 and 200. So from this X-ray pattern, we clearly understand that the purity of the sample is very high because we got that high intensity and as well as the highly crystalline nature of this composite. And next, we perform this FTR analysis. The FTR analysis, we done that you can see the lower frequency region, which is the copper and oxygen switching of vibration. It is the range of 670 centimeter inverse one, and as well as the graphene carbon nitrate. What is the frequency? The functional graphene carbonate switching vibrations occurred at 1634 centimeter inverse, which is confirmed this composite. And as well as we've done this UV, the simple one, maximum absorption 470 is the visible range, and band gap value we calculated this 2.3 electron volt. Yeah, you can look at here this beautiful morphology of this different magnification of this composite. You can look at here A and B is the graphite, and C and D and EF is C and D is a cuprous oxide, and E and F is a composite. How you know that the sheet-like morphologies we observed from that A and B, and C and D is we controlling the size. When you just controlling the size by using that different precursors in hydrothermal method, you can get the different morphologies. We got that octahedral shape of these morphologies for this cuprous oxide, and then E and F, you can see the composite, how it is wrapped with that graphite sheet. You can clearly see that E and F is which is confirmed is how that octahedral shape of this cuprous oxide is present in this sheet, which is confirmed by SEM analysis. And then next, you can see that there are two spectrum of this compound. One is represented by the cuprous oxide, and next one is represented by the composite. You look at here the different time interval of time is 0 to 90 minutes for A, and then B is different 60 minutes to composite, easily divided 60 minutes. So from this, by using for 4 dyes, different dyes for methylene blue and dotamen green, diamond blue and blue ink, you can look at here which one is the maximum absorptions when compared to this previous one. You can look at here, this one is blue high ink is a high absorptions when compared to this dotamen B is a very high absorption when compared to this other dyes. And as well as we done that degradation dye efficiency. But you can look at here compared to other dye, we tried with different dye, and we can which dye is completely dye degraded. We are using for different organic dyes. You can look at here industrial dyes. You can see that methylene blue is showing for maximum of dye degradation percentage when compared with that other. And as well as that dark and visible light, and we look at here, there is no change in the dark region, and but in visible light is significantly changes happen, and we calculated. And then the stability test we performed. That the stability test, we can see that there are 4 cycles. From this 4 cycle, you will look at here clearly, that shows a better stability. And the declaration efficiency of these 4 dyes like methylene blue, rotamen B, diamond blue, and blue ink, even after this 4 cycles run. Then you can look at here this generally, how the oxygen vacancies play an active role in the dye degradation process. As a postulated, how the electrons are excited energy levels gets by the surface, absorbed by this oxygen or water molecule to generate the highly active radicals and super radicals. So these oxidative reactions of such formed radical spaces with that 3 dyes, and then to generate these degraded products. So maybe we are.
Dr. Suresh, can you conclude?
Yeah. I'm coming to the conclusion.
Yeah, thank you.
Talk, is a successful formation and fabrication of this 2 composite with 2 metal oxide, combined with that graphene carbonate, and then we performed that physical chemical characterization, and then we done that photocatalytic performance by organic dyes, and finally we done for this some kind of quite catalytic activity. But in future, we try to do for our result in the industrial, water splitting, wastewater treatment. So the commercial application, we can proceed for our this research work. In this occasion, I should thanks to my all collaborators. They are giving for full support and coordinations. I also collaborated with from your university, Dr. Seema Gork, and she's also very good collaborator for me. And then we done a lot of works and we published paper together. So I should thank to everyone. In this occasion, I should thanks to for Seema Gork giving this opportunity to present the student result in front of you. And also this is for one kind of simple, advertisement and information to all student community. We offered for Master of Applied Science in the nanotechnology. Those who are interested, you can study for 1.5 years course in UM. There is no entrance exam, just you can go for your process. Our standard launched this MSc program for this course. Actually, our center have that two kind of program, moderate program, course program, and this research program. We have already research program. This is a course program. That's all for me. Thank you. Thank you very much for your patience. If you have any questions, please.
Thank you, Dr. Suresh. The session is open for question answer. Any questions from the audience, students? Please ask questions. Yeah, please.
Thank you, Dr. Suresh, for wonderful talk.
Oh, thank you.
The one small question from my side. You showed the photocatalytic activity of the prepared material. Did you show scavenging activity also? Which species mainly responsible for the degradation?
No, that one we are not done. Still, we are processing. Only we done that photocatalytic activity.
Okay, thank you.
Yeah. This maybe my student we extend for this work for other applications, and we can extension for this commercial work, commercial basis.
Thank you, Dr. Suresh.
Yeah, it's my pleasure. Any students from your side? Maybe my talk should be very simple and I'm not giving any advanced techniques or advanced research because I saw that this is a symposium, which means that the student gathering, and I can give that the simple thing.
Oh, talk was very good, well elucidated. In fact, we have also used zinc oxide nanoparticles to make a nano biofertilizer.
Yeah,
so nanocatalysis definitely enhances the productivity.
Yes.
Thank you.
Okay. Thank you all. Once again, I thank you for all organizer, committee members and faculties for Amity University. Thank you all.
Thank you, sir, for such an informative session. Now, I would like to introduce Dr. Praswan Kumar Roy. Dr. Praswan Roy is presently working as Scientist F, and he is heading the Protective Clothing and Materials Group at the Center for Fire, Explosive and Environmental Safety, DRDO, Delhi. He did his graduation from Hindu College, Delhi University, followed by MSc from IIT Delhi, Department of Chemistry, followed by MTech and PhD, both from Center for Polymer Science and Engineering, IIT Delhi. He is also the recipient of the Boyce Cast Fellowship from DST, under which he did his postdoctoral research in Royal Institute of Technology, Stockholm. He has guided many PhD students, and his research interests include development of degradable polymers, polymers for blast mitigation, and fire protective clothing materials. He has around 93 international research papers and 6 patents to his credit. Over to you, sir.
So good afternoon, rather still good morning. Well, it is indeed an honor for me to be here, and I'm very thankful to the organizing committee for having given me this opportunity to meet you all today and share the work which DRDO does. And usually, when I got this request from Dr. Pratibha, she happens to be my PhD student. She asked me to give this invited lecture, so-called, and yeah, so I was kind of taken aback because DRDO is usually not known for chemistry. It's usually known for missiles and stuff. So I asked her कि audience क्या होने वाला है? तो उसने बोला सर ये अपने बच्चे होंगे. So I said, well then it's really good because you kind of get an idea what you're going to do later in your life. I mean, many of you are going to become scientists, researchers. So my topic is going to be something which should be of interest to you, but not something which usually you come across. It's basically protective coatings for blast mitigation. So blast is something जो usually पढ़ाया नहीं जाता है. not know MIT में course में है कि नहीं, but हम लोगों को तो नहीं पढ़ाया गया था blast कुछ पहले भी. So with this brief introduction, I'll start. So the topic today is selecting building blocks for tuning material properties of ये क्या हो गया? Tuning material properties of polyurea coatings. So ये कहाँ पे करना है? Yeah, thank you. Yeah, so before I enter into the main thing, I would like to give a brief introduction of the kind of loads you all deal with. So, load जो है, either it can be man-made or it can be natural or it can be static or dynamic. So, man-made load, आपको पता ही है, any kind of load which you are applying is a man-made load. And natural is something जो automatically है. आप लोगों को तो बहुत ज़्यादा है. अभी फिलहाल तो MSc कर रहे हैं तो लोड ही लोड है सारा पढ़ाई करने का. So वो load नहीं. I'm talking about physical loads. So physical load में usually it is static or dynamic. I mean usually क्या यही हो सकता है और कुछ हो ही नहीं सकता है. Static is something which is always on you on the structure. So let's say this is the structure और इसके ऊपर जो भी load है that is always there. So that is called a static load. And the other load is dynamic load. So dynamic load is something for which usually buildings are not designed. So जैसे there are many buildings in our country which were initially envisaged as ordinary buildings, but then अब वो strategic हो गए हैं. So now if they have to be protected against blast, let's say tomorrow you come to know that इस जगह पे एक terrorist threat है. So उस terrorist threat से आपका blast होने वाला है और आपको अंदर के बंदों को बचाना है. So the building originally is not designed to withstand this kind of blast load. So ऐसे cases में क्या करना है? That is what the thing is I'm going to talk about today. So this is what do you call? Usually loads जो हैं, they are defined in terms of their amplitude and frequency. So जो load बहुत short duration के लिए होगा, so frequency you know is one upon time. So जो short duration के लिए होगा, that will be high frequency. और जो long duration के लिए होगा, that will be for a very, I mean, it's a small frequency. So अगर आप देखें, ये आपके जो normal loads हैं, let's say acoustic load. Acoustic load has a very high frequency, but its amplitude is, you know, हल्का है. So इससे बंदा को कुछ होता नहीं है. Acoustic load से of course आजकल TBI आप लोगों ने सुना होगा, I do not know, traumatic brain injury. So that kind of thing can happen with a acoustic load, high acoustic load. फिर हो गया अपने seismic, अभी कुछ दिन पहले हुआ earthquake दिल्ली में. So that's a seismic load जो आया चला गया. So the frequency is somewhere here. But what I'm going to talk about here is a blast load. So blast load is something which has got a very high amplitude, intensity भी बहुत ज़्यादा है और उसका frequency भी बहुत ज़्यादा है. Okay, so the time duration is very short. तो अगर आप झेल गए तो झेल गए, वैसे chances तो कम ही है. But that is the kind of load for which so that was the project basically. So develop coatings which can protect the people inside a building against blast loads. So blast loads, very high frequency, very high amplitude, और उसके against काम करना है. Yeah, so what is a blast? Basically, अचानक से if something gets converted into gas, any small amount of material, if it gets converted into gas in a very short duration of time, that's called blast. So यहाँ पे we can see this is nitrocellulose, so 227 grams of nitrocellulose if you take, and all of a sudden, let's say it gets converted into gas. So 227 grams gets converted into 171 liters of gas in a matter of nanoseconds or milliseconds. So itna sara volume in a matter of a very short duration, it's definitely going to cause something. And that phenomena is called blast. Now, I have a video here, sir. May I request you? जो आपने रखा हुआ था, pause करके रखा हुआ था जो. So basically, okay. Can I speak? Oh, okay. So, blast को हम लोग usually जो Iron Man या वो सब में देखते हैं. So now can I have the presentation please again? Anyway, so now I'll come back to this thing. Can I have the next slide, please? So this is just a graph between pressure and time. So यहाँ पे सारे chemistry के ही लोग हैं और we have a mixed audience. सारे chemistry के ना? Okay. So ये थोड़ा सा मेरे को थोड़ा time लगा था समझने में when I was doing this job, but this is basically a pressure time graph. So when a blast wave hits you, ये चीज है, अचानक से pressure बहुत बढ़ जाता है. So a lot of gas is hitting you in a matter of, let's say, a few seconds, nanoseconds or milliseconds, जो भी है. So pressure suddenly बहुत बढ़ जाएगा, and then it'll go down, and then it'll go below normal. So it will create a vacuum. Here the pressure is even below, what is atmospheric pressure. So it's going to be a vacuum here. और उसके बाद it will come back to normal. So अगर कोई structure ये वाला time period उसको झेल जाए, so all is fine. But ये usually होता नहीं है. Depending upon कितना pressure है of the कितना मतलब कितने kilos of TNT फोड़ा गया है by the terrorist, उसके ऊपर depend करेगा कि damage कितना होने वाला है. So the damage due to a blast is basically because of that shock wave जो आपको दिखा वो कोने में सुंदर सा. It also causes ground acceleration. It leads to fragmentation, and this fragments जो form हो रहे हैं, when they hit the person who is inside the building, it's going to cause damage, spalling and heat radiation. And in the event of a bomb explosion or a blast, it's basically the debris of the building which causes the major damage to the people who are inside. So this is how the scenario is like. The blast wave breaks the windows first, जो expected है, जिसका सबसे ज़्यादा कम strength है. Then the exterior wall gets damaged. Then columns may be damaged. The floors are pushed upwards. And then subsequently the blast wave, it surrounds the entire structure, and because the pressure, the entire building collapses. I mean, जितना भी damage होना है. These are few photographs. Oklahoma City bombing, a very famous bombing, जिसके अंदर सिर्फ 2 लोगों ने पूरा ये कहर ढाया था. So it was basically TNT and some also which they made at home, साबुन वाबुन से बना के ये इतना बड़ा डैमेज कॉज किया था way back in 1995. ऐसे कई damage to US embassies, damage to railway stations. These are very common things which we normally see. So what are the existing solutions? अगर आपको बोला जाए कि ऐसा करना है, किसी बिल्डिंग को बचाना है, what are the existing solutions? The existing solution is maintaining a sufficient standoff. जो आपने पठान में भी देखा होगा, वो जब जा रहा था जाने का, वो पुल अप करो. So pull up करो मतलब basically bollards, they come up underneath, they are placed in such a way कि वो ऊपर आ जाए, तो जो ट्रक है वो अंदर ही ना आ पाए. तो इतना डिस्टेंस रहेगा. So अगर आपने देखा होगा वो PT diagram, it falls off exponentially with time. So आपका अंदर का जो बिल्डिंग है उसके ऊपर वो प्रेशर ही नहीं आ सकता. So that way the building is protected. So first is maintaining a sufficient standoff distance, which is practically impossible in आज के देश में, आज के टाइम पे in Delhi like scenarios. then adding steel rods, which can basically strengthen it more. Then we can have a catcher system wherein जो भी बन रहा है उसको पकड़ के रखें. Retrofitting fiber reinforced polymers, retrofitting this structure, let's say with, अभी यहाँ पे तो सब facading कर रखा है with decorative चीजें, but अगर इसको protect करना होगा, then we'll have to put something which is stronger. So FRP के साथ आप कर सकते हैं. And the last one, spray on polymeric coatings, जिसके ऊपर ये entire lecture है. Now, here what we are talking about is retrofitting. Retrofitting is something जो existing के ऊपर किया जा रहा है बाद में. If we already know that this building के अंदर attack हो सकता है, then we design the building in a way कि उसके अंदर कुछ होगा तो वो झेल जाएगा. But practically हमें पता नहीं होता है. We just come to know कि कुछ दिनों बाद यहाँ पे हो सकता है. So we have to retrofit the existing building with something. So this is a retrofitting thing. So we have to retrofit the building with something जिससे कि काम बन जाए. Modifying the existing structure with additional components or members, and the process of strengthening the existing buildings in order to make them resistant to blast effects. So recent practices में you would have I do not know, ये FRPs को अगर आपने मेट्रो के कॉलम्स में भी देखा, मैंने एक जगह पे देखा था, मेट्रो के कॉलम के ऊपर इस तरह का एक FRP को कोट कर दिया गया है, FRP लगा दिया गया, जिससे कि इन केस ऑफ कुछ अगर हो जाए, यहाँ पे ब्लास्ट होने का तो चांस आई डू नॉट नो है कि नहीं, बट कोई अगर चीज अचानक से इम्पैक्ट कर जाए, सो वो FRP उसका जो ग्लास होगा या जो भी होगा उसके अंदर जो फाइबर यूज किया जाएगा वो इतना स्ट्रांग रहेगा कि वो won't allow the entire thing to collapse. And FRPs, why are they famous? Because they have corrosion-free characteristics. They are relatively cost-effective as compared to the other solutions. तो ये कुछ examples हैं जहां पे ये use होते हैं. Now, there are certain limitations of these fiber-reinforced polymers. So पहला limitation यही है कि कई सारे layers, अगर आप लोगों ने किसी ने भी आप students ने अगर काम किया होगा with composites बनाने का, you would have seen आप ग्लास लेते हैं, उसके ऊपर आप इपॉक्सी या जो भी आप लेते हैं और उसको फिर लगाते रहते हैं, then you compression molding और फिर आपको वो मटेरियल मिलता है. To get the kind of protection you're looking for, आपको बहुत सारे layers लगाने पड़ते हैं. It's a very cumbersome process, not something which is very easy. In case of close-in detonations, the strain demand is beyond the strain capacity of FRP. उसका मतलब ये है कि कोई भी चीज है वो अगर उसका strain कम है, stress strain curve में बहुत जल्दी टूटता है, elongation कम है, वो FRP is such a kind of a material that उसका strain is less. And the main problem ही FRP का यही है कि इसका strain in detonation is failure strain is very less. So as a result of which this इससे भी बेटर कोई सोल्यूशन अगर हमारे पास है, सो द सर्चेस कहा गया था करने को. सो ऑल्टरनेटिव इज elastomeric coatings. So polyurea coatings, they are pretty in vogue now. So basically this has been used by the US Air Force. And पहला काम in fact US Air Force ने ही किया था इसके ऊपर, wherein they used it, it's in fact being used in Pentagon. नाम सुना होगा आप लोगों ने. So Pentagon के inner जो walls हैं उसके अंदर ये polyurea coating लगाई गई है. अब interestingly हर कंपनी कहती है कि मैंने लगाई है polyurea coating Pentagon पे, but still nobody knows कि actually किसका polyurea coating लगा हुआ. Up armoring of high mobility multipurpose wheeled vehicles, ये जो इतने सारे wars होते हैं जिसके अंदर आपका इसमें भी था, I think Iron Man 2 में था शायद, जिसके अंदर bullets are being sent and they basically puncture the tank, fuel tank. जो fuel tank है of these high mobility multipurpose vehicles, इसके fuel tank अगर fuse हो जाए, अगर penetrate हो जाए तो the fuel comes out. And when the fuel comes out, that can catch fire and that will cause a lot of damage. So, polyurea coating is something जिसके बारे में इंडिया में कोई भी काम नहीं करता था. The reason solely being because it is primarily a defense activity. क्योंकि ये कोई भी जो है घर पे ऐसे polyurea coating नहीं करना चाहेगा for. So it's a defense activity. So we were asked to take it up. So what basically happens is कि ये आपका बिल्डिंग है, मेसनरी स्ट्रक्चर है, उसके पीछे अगर आपने एक पॉलीयूरेथेन कोटिंग लगा दी, so in the event of a blast, what will happen is this will basically hold back all the fragments and giving the people enough response time to move out. So polyurea बनाने के लिए जैसे very similar to polyurethanes, it's basically reaction product of isocyanate with amines. Instead of polyol, we take an amine. So normal जो अपना reaction है n iso is equal to n amine m amine, वो तो है ही, but इसके अंदर problem ये है that the reaction time is very fast. So this reaction takes place in a matter of seconds. So मैं आपको एक वीडियो भी दिखाऊंगा जिसके अंदर आप देखेंगे कि ये लगाते ही in a matter of 4-5 seconds the thing solidifies. So आप इसको ब्रश से कोट नहीं कर सकते हैं. So you need a spray coating machine to do this operation. So ये आपका आइसो हो गया, और ये सारे अमीन्स अगर आप पॉलीयूरेथेन पे भी काम किया होगा आपने देखे होंगे there are so many different kinds of polyols. Similarly there are so many different kinds of amines. कोई लॉन्ग चेन है, कोई शॉर्ट चेन है, कोई चेन एक्सटेंडर की तरह काम करता है, कोई क्रॉस लिंकर की तरह काम करता है. एंड दैट इज इन फैक्ट द टॉपिक फॉर टुडे, ट्यूनिंग, कि कैसे हम लोग ट्यून कर सकते हैं द मटेरियल्स, कौन से मटेरियल सिलेक्ट करें जिससे कि हमें वो प्रॉपर्टीज मिले व्हाट वी वांट. सो polyurea, very much like polyurethanes, they have a hard segment and a soft segment. Hard segments, they basically act as, they look very much like आपके FRPs. So this is the AFM image of polyurea. So अगर आप देखेंगे ऐसा लगेगा जैसे इसके अंदर बहुत सारे धागे हैं. So basically these are the hard segments which are a result of hydrogen bonded structure. Polyurea exhibits a bidentate hydrogen bonding, as a result of which the mechanical properties are far superior as compared to polyurethanes and far expensive also. So ये आपका structure जो है, it looks like an FRP. हाँ, तो M amine तो हो गया, but the problem इसके अंदर है कि ये जो मशीन होती है इसके अंदर we have to maintain a 1:1 ratio. So आपका जितना अमीन एक टाइम पे जाना है उतना ही आइसोसाइनेट एक ही टाइम पे निकलेगा. So both these things are placed in different containers. ये जो है इसके अंदर एक तरफ में अमीन रहेगा, एक तरफ में आइसोसाइनेट रहेगा. Both of them they go out, meet in the nozzle and sprayed onto any surface which you want to coat. So जो पहले के reactions होते हैं वो आप लोगों की तरह ही बिल्कुल फेलियर थे. ये what we got was fibers. We didn't get any kind of coating. We just got a noodle like product. और उस वक्त बहुत ही डिप्रेसिंग स्टेज होता है कि ये क्या बन गया, क्या बनाना था, क्या बन गया. Then we realized that we had to do a viscosity modification so that both these things एक ही टाइम पे एक ही the amount of liquid coming out should be the same. So इसीलिए we had to choose a this is called a propylene carbonate. Basically it's used as a diluent for the isocyanate, और इनका viscosity has to be matched so that equal amounts निकले at equal point of time. So difference in the viscosity of isocyanate and amines lead to stoichiometric imbalance, जिससे कि property जो है खराब हो जाता है. So we have diluted with 10%. So this is application process. सर एक वीडियो होगा application का.
Sir, we have to conclude also in 5 minutes.
Application. Since we have to conclude in 5 minutes, what I'll do is I'll just show you 3 or 4 videos जिससे कि आपको पता चल जाए कि what we did. So this is what actually is done. अगर आप देखें एक तरफ से आइसोसाइनेट आ रहा है, एक तरफ से अमीन आ रहा है. They are meeting at the nozzle, and when they are coated on this, when they are sprayed onto any surface, या आप सिर्फ ये तो मैंने एक स्टील प्लेट के ऊपर किया है. This can be done over any surface. So you can see अभी कोट किया है, and in a matter of seconds, 3 or 4 seconds, this is already a solid. So इसको you cannot process using any other technique. ठीक है? So when we had to make, you can see थोड़ी देर बाद तो इसको आप press भी करेंगे, you will not get any indentation also. Okay, so basically this is the main thing about polyuria. So अगर आपको कल को बोला जाए कि so and so बिल्डिंग के अंदर ऐसा एक अटैक होने का चांस है, तो यहाँ पे उसी वक्त उसको खाली करा के this entire thing would have to be coated. Okay, खुदा ना खास्ता कभी मजबूरी पड़े, पर अगर करना पड़े तो we have a solution at hand. Okay, next. सर मैं आपको बोलूंगा सर, आप दूसरे वाले वीडियोस जो है नीट टाइल, एक नीट होगा और एक कोटेड टाइल, वो प्ले कर दीजिए बिकॉज आई हैव टू एनीवेज कंक्लूड. आप भी कर दीजिए. सो बेसिकली वी मेड दीज. अब इसको प्रूव कैसे करेंगे कि आपका ये बन गया है, whether it is able to prevent the fragmentation. So what we did was, this is called a shock tube. This particular thing, this is called a shock tube. इसके अंदर we can create a blast, जो कि normally create करना difficult होता है. So this is called a driven section. इसके आगे एक टाइल लगाया हुआ है. ये टाइल के ऊपर हम लोगों को एक ब्लास्ट करना है. ठीक है. सो हम लोग एक जगह पे, ऑन द अदर हैंड इस तरफ, दिस इज वेरी लॉन्ग ट्यूब. ट्यूब के एक साइड में हम लोग गैस भरते हैं, एयर. वैसे नाइट्रोजन भरना चाहिए, पर एयर भर के एक पर्टिकुलर जब वो प्रेशर आ जाता है तो उसको फोड़ दिया जाता है. एंड व्हाट हैपेंस इज दिस एंटायर gas, in a matter of seconds, it comes and it hits the surface. तो यहाँ पे दो वीडियोस हैं, आई डोंट नो कौन सा वाला चला है. एक वीडियो है जिसके अंदर ये है अगर आप देखें नीट टाइल, एक नॉर्मल कंक्रीट टाइल के साथ ये होता है. अगर आपने देखा होगा, दिस इज व्हाट हैपेंस, द एंटायर थिंग इट जस्ट शैटर्स, एंड जो भी बंदा ऑन द अदर हैंड साइड होगा उसका तो हालत खराब होना ही है. नाउ आई विल रिक्वेस्ट यू टू प्ले द अदर वीडियो. कोटेड, अगर इसी को कोट कर दिया जाता है विथ अ पॉलीयूरिया, सो देन व्हाट हैपेंस. सर इसमें आप 1 मिनट पे चले जाइए, 50 सेकंड्स पे. आई थिंक नहीं हो रहा है इसमें. हाँ, सो यहाँ पे जब ये हुआ, सो यू कुड सी दैट द फ्रैगमेंट्स, आई मीन जो भाई बंदा इस तरफ में है, he is basically safe, because even if there is a fragmentation, it is not able to go to the other side. Okay, so basically this is, I will not go into, बाकी बहुत सारा chemistry था, पर मतलब देख के लग ही रहा है कि बोर है. तो what we'll do is we'll skip that, and this is what this thing was all about. वैसे एक चीज बस याद आई, जब आप लोग घुस रहे थे ना, शुरू में जब आया था मैं, वेरी सिमिलर दैट ऑफ बाउ प्रिंसिपल जो हम लोग पढ़ते थे, कि लोअर एनर्जी वाले पीछे बैठे हुए हैं, फिर अचानक से शायद कोई क्लास खत्म हुई होगी, दे वर फोर्स्ड टू कम इन, तो वो सारे आए, दे गॉट फिल्ड इन हियर, ये पूरा भरा जैसे वो 4S भरता है बिफोर 3D, एंड देन पीपल डिडंट वांट टू गेट सिट हियर बिकॉज़ यहाँ प्रोफेसर्स थे. तो बिल्कुल वैसा ही माहौल था. और फिर अचानक से शायद एक और क्लास हुई जब 4S वाले सारे निकल गए. वेरी सिमिलर टू व्हाट वी यूज्ड टू हैव इन आवर टाइम्स. मैंने देखा 20 इयर्स डाउन द लाइन कुछ चेंज नहीं हुआ है. हमारे साथ भी यही सिनेरियो था. So anyways, so this was what my my lecture was all about. Thank you so much. Any questions? Thank you, sir. Any questions? Polyuria. Yeah.
Thank you for a well-delivered talk. My question is regarding this. Normally, these polyurea coatings are moisture sensitive, right? So, when you use in coatings, it's a challenge. So, how did you address this?
Very good point. But actually, polyurea coatings are not water sensitive. It's basically the isocyanate part. So when we use slightly excess, 5% excess we use, because we have to take care of that only. So slight excess of isocyanate is taken to take care of that. And but when we do polyurea coatings as such, we determine the chemical resistance of this material against different kinds of solvents. Okay, so It was water में तो बिल्कुल भी नहीं. There's no swelling even after 5 days of this thing. कुछ नहीं होता है. Polyurea is a very chemically resistant. इसका shelf life is told to be 20 years. Shelf life of polyurea material. And so basically the talk was on that, but मतलब सिनेरियो ऐसा था कि वीडियो दिखाते दिखाते टाइम खत्म हो गया. So if you increase the amount of crosslinker in it, so we had chosen a crosslinker 5000 molecular weight. So you can increase the chemical resistance also by increasing the amount of crosslinker.
So I have a question. So polyureas are elastomers, but we have a list of elastomers already available commercially. Why not use them? Like we have sprayable silicone coatings. So what makes polyurea special over silicone resins?
Absolutely brilliant question. And now the reason why, अगर आप let's say एक पॉइंट जब हमारे शुरू के ब्रेनस्टॉर्मिंग सेशंस होते थे, जब भी हम कोई प्रोजेक्ट लेते हैं उससे पहले ब्रेनस्टॉर्मिंग सेशन, तो उन्होंने कहा कि आप इतना कुछ कर रहे हो, आप लोग टायर का वो क्यों लगाए थे, जो ये टायर होते हैं एयरक्राफ्ट के टायर्स, दे आर आल्सो मेड अप ऑफ रबर्स, सो व्हाई डोंट यू अप्लाई इट लाइक जस्ट लाइक दैट. इट्स अ ब्रिलियंट सजेशन, बट देन द पॉइंट वाज कि आप जब इनको लगा रहे हैं, इट्स बेसिकली द एडहेशन. अब वो जो रबड़ है उसको जब हम लोग किसी सरफेस के साथ कोट करेंगे, so basically you would have to apply another adhesive in between. So आपकी property जो आ रही है वो is dependent primarily on that adhesive, so that entire polymer can come out. Okay, so the entire rubber जो आपने लगाया वो निकल के बाहर आ गया, and then your surface remains just like that. The main property about polyurea, why it is considered to be the best material for this particular purpose, is that इसका जो ये operation time है वो बहुत कम है. जो बाकी नॉर्मल रबर्स है, इवन नियोप्रीन कैन बी यूज्ड, पर नियोप्रीन को आपको डिसॉल्व करके उसको फिर स्प्रे करना पड़ेगा. ठीक है, तो इट विल यूज सम वोलेटाइल ऑर्गेनिक फॉर योर व्हिच इज गोइंग टू कॉज दिस. आई मीन अभी तो 3-4 लेक्चर हुए अभी एनवायरनमेंट के ऊपर, तो वो तो पहले ही मना हो जाएगा कि इतना टोलुइन का यूज कर रहे हैं. सो बेसिकली व्हेन यू टॉक अबाउट practical application, polyurea was the best choice, and that is the reason why we went for this. Silicone, of course, we can, but silicone ke andar what we observed that the tensile strength of silicone was relatively lesser as compared to polyurea. That is the reason why we chose polyurea. But there is no foundation. Any rubber is going to work the same way if we are able to get the kind of tensile strength we are looking at. Okay. Thank you.
Thank you, Dr. Prasoon.
Thank you so much, sir. Now we have among us Dr. Bhanu Pratap Singh. We welcome you, sir, and we kindly request you to please join us on the dais. We request Dr. Amit C. Kharakwal to present the saplings to Dr. Bhanu Pratap Singh. Thank you so much, sir. Now we would like to introduce Dr. Bhanu Pratap Singh. Dr. Bhanu Pratap Singh is a distinguished senior principal scientist at the Advanced Carbon Products and Metrology section of CSIR NPL, New Delhi, India, and a professor at the Academy of Scientific and Industrial Research, ACSIR, Ghaziabad, India. With over 18 years of research experience in the development of advanced carbon products, Dr. Singh is a renowned expert in the large-scale synthesis of carbon nanostructures and their advanced nanocomposites for various applications such as structural anode material for lithium-ion batteries, efficient EMI shielding materials, ballistic materials, and water purification. He has published 143 research articles in prestigious international journals with 8,700 plus citations and 50 H index, 2 books, 14 book chapters, and has 4 patents. Dr. Singh has received several awards, including the NRDC National National Meritorious Innovation Award, the IEI Young Engineer Award, the CSIR Young Scientist Award in Engineering Sciences, and the Ham Young Scientist Award. He is also a life member of several research societies and the Joint Secretary of Indian Carbon Society. Over to you, sir.
Thank you for the nice introduction. First of all, I would like to thank the organizers who invited me for giving a talk here. So basically, today talk is on carbon nanotube incorporated activated carbon for dye removal from the wastewater. As the theme of the conference, basically more on the chemistry. So I'm just trying to speak on this water purification with having some kind of information about the young students also, adsorbents, reaction kinetics, so slightly useful for them also. My field basically on the research is on the carbon nanotube for structural composite, as the previous speaker, Dr. Prasoon, speak about CFRP composite, FRP composites. But today we are just going to talk on the activated carbon and the carbon nanotubes. See, as we know, the water is very important, and nowadays we are in the scarcity of the water, for the good quality of water, especially for the drinking water. Also, we are surrounded by 71% of the water with our Earth, in which the ocean. But that water, you can see, and 97.5% of that water is salty water, so that we cannot use. Only 2.5% water that can be useful. That's basically the fresh water. And on that 2.5%, you see, in that 2.5%, 7% of that water is used for our household application, you can say municipal purpose, and 6% for the other application, and then 7% for the industry. After that, this I am not able to see. I but bring it to the 70. And that agriculture also, there are a lot of requirement of water, around 76%. Okay, so you see, we need the industry which having a requirement of water is around 7%. That basically industry, when they're using the water, that's basically creating a lot of pollution on that, the pollutant water. So the focus of today's talk is how to improve the quality of that water which the industry is using. Okay, so what there are different causes and the effects of the water pollution on that. Can I come here? That will be good, I think. Thank you. But it is connected? No? Okay. One more thing, yeah, please. You remove this top part. Okay, that's then title will come. Top part, this will come. Okay.
Sir, this is not coming in the PPT. Actually,
okay, so then title will again not be seen. Okay, thank you. So, yes, sorry for the interference. Okay, So basically, what are the causes and the effects when you talk about the water is polluted by the industries, so or by any other purpose? You can see the microorganism or the virus, bacteria. That's basically creating the problem of diarrhea, cramps, nausea, headaches, fluorides, also the dental fluorosis, tooth discoloration, and bleaching of the different kind of problems basically occurring due to this problem in the water or water pollution. So one of the things which I am just focusing today is the dyes. You know, the dyes is basically used in the industries, especially in the textile industries. Textile industries, what is happening? We have a simple type of a cloth, then it has to be colored. So this should be dye are used. So when we are using the dye, lot of water is used, and that dye basically contaminates this water when it go to the come out from the industry. So, but the problem basically occurs by using that kind of water which containing dyes. This is respiratory diseases such as asthma and some kind of skin irritation. So we need to purify that water which is containing the dye. So we will focus in this talk today. And we can see a lot of time from the newspaper what is happening due to the color impurities, the steams and destruction. You can see the pulpal therapy. So many news articles are available. So, due to the problems which are coming from the industry as a water pollution. Okay. Now you see this organic dyes as a water pollutant. Major source of dye is the textile, which I am talking about, paper industry and the leather industry. More than 7 lakh metric ton of dye produced annually worldwide. And when this dye is basically produced or it is used for the textile industry, around 60 to 70% of water is untreated. That's just created as water pollution. And see one example of that. Average water consumption for the dyeing of 1 ton of cotton cloth. When you have a cloth of 1 ton, but how much requirement of water is there? It's around 200 to 250 meter cube. 1 meter cube equal to 1000 liter. You talk about, forget the 1 ton, you can consider a 1 kg. If 1 kg of cloth needs, you convert the liter to 1 meter cube, that means 1 kg of the cotton cloth need to 200 to 250 liter. 1 किलो के लिए 200 से 250 लीटर पानी चाहिए आपको उसको करने के लिए. That means around 8 ton of fabric per day, basically in the small scale industry is basically producing. So the large amount of water used, which is basically creating a problem with this textile industries. And there are a lot of regulations and the regulation as per the Bureau of Indian Standard, the ISO 1050 1991. You can see there should be a color halogen unit up to the 5, but they are permitted up to the 25. In order, they're unobjectionable. Okay, the taste should be agreeable, and the turbidity 5, and the just can go up to the 10. And the pH, there is no compromise on the pH. So these numbers are also given that when you are leaving the water after the production in the industry, it should not cross these limits. What are the effect of these dye effluents? That also affect the plant species. In which manner? So basically the intercept photosynthesis activity, decrease the soil quality, affect plant growth. It also create the problem with the aquatic animals, increase level of danger of life of the aquatic animals. Environment, it also change the CO2 and BOD values. And the human being, you say that is hazardous disease, which I also discussed in the previous slides. There are some solutions, okay? There are for purifying this kind of impurity in the water. There are some remediation technologies available in the already. You can say what one of them is bioremediation. In the bioremediation, but every remediation process having some kind of limitations. So people are always trying to better process to implement in the better way and the better performance. So bioremediation basically is a very slow process. The treatment time typically longer than the other technology. Another thing is ion exchange. And ion exchange is a expensive technology. Treated water having a slightly not exactly what requirement of the pH value is there. It's also containing high chloride, high chloride contaminations. Then electrolysis is one of the process. It's basically the cost of basically it is used with the help of electricity. So electricity cost is also included on that. And the coagulation precipitation technique, the test of water change basically. Maintenance cost is high and big space needed as a dry sludge is used for this kind of purpose. Produce highly concentrated sludge in the membrane filtration. Dissolved solids are not removed by this technique. So there are some kind of limitation for the existing technology. One of the very common technology which is used in the industry that is called adsorption based. Okay, adsorption based technology is a high performance. It's a very cost effective. You need an adsorbent. It's easy to operate. It's a recyclability, environmental friendly also, and the biodiversity of the adsorbent. So there are different kind of adsorption materials are there. So you can say type of adsorbents. Biosorbents are also used. Oxide and hydroxide of metals. Industrial waste can also be used as a good adsorbent material. And the more common is basically carbon-based adsorbents. As we all know, the charcoal is a very good adsorbent material, or activated carbon is used in so many applications. If you are having in your home, this RO system, every 3 months or 6 months you are changing the candle, this is containing the activated carbon. People are using the cosmetics nowadays, that's also having activated carbon. It's a good adsorbent because of a large surface area and small size pores that absorb the toxic element very easily. So not only for the water purification, there are large number of applications. Chemical industry, people are using activated carbon or carbon for the good adsorbent material. Now, what are the sources? What are the sources of these adsorbents? Biomass is a very potential energy source. The supply are not limited because waste related with the tree and crop will never be finished. That will always be available. Okay. So what is coming from the waste from these biomass? We can use it as a raw material for the adsorbent. So what are the sources? The sources can be the forestry crop and residue, agro, MSW, animal processing, agriculture, and crop residue. Other than that, there are some wood are also used as a material for adsorbent, and some kind of a cotton. When you are growing the cotton, there are some sticks and the other waste material which is after removing the cotton. That also just like a work as a biomass for the using this kind of adsorbent or other purposes. Bean, rice, pulses, sunflower, sugarcane, peanut, and these all comes into the category of agriculture residue. So we see the agriculture residue cheaper than conventional precursors. It utilizes low cost, multiple feedstocks, availability at no cost, or sometimes very low cost. Okay. So this is basically a bulk production of this kind of adsorbent is also possible. So it's a cost-effective process. So by using the biomass as a source material for the adsorbent can be utilized for such kind of application. When you talk about the chemical structure of different kind of biomass, just basically containing 3 different structure. One is the cellulose, lignin, or hemicellulose. Now in this presentation, I'm focusing on one biomass on which we have done some studies. That is basically eucalyptus bark. We know there are trees of eucalyptus. There's a bark is just putting on that eucalyptus tree. So that's coming out. So generally, that's just like a waste. Okay. So in every year, around 1.5 lakh hectare of eucalyptus plantation comes in India. And it is widely grown in Tamil Nadu, Andhra Pradesh, Gujarat, Haryana, Mysore, Kerala. Sometimes you can also see in the northern part also. So this, the bark of that material is just like a waste. So what we try to do in the laboratory, we are trying to make the activated carbon from this eucalyptus bark. Okay. So what we did, we have some kind of eucalyptus trees are also available in the National Physical Laboratory. We have the bark of that. We take that bark of this eucalyptus and then make a powder. अच्छा not अच्छा नहीं लग रहा अच्छा eucalyptus bark. अच्छा eucalyptus bark powder, and then you make a powder of that. The powder size is around 50 mS. This is passed from the 50 mS screen, and then what we did, we need some kind of activation material. So activation agent, what we are taking is the orthophosphoric acid. To take the orthophosphoric acid, and the temperature was kept to the 550 degrees centigrade, but basically optimized from the 500 to 800 degrees centigrade, in which we have to see what is the surface area as well as how much a percentage of conversion from biomass to activated carbon takes place. So this we have the optimized to 550. Then rate to reach the 550 degrees centigrade is 5 degrees centigrade per minute. So rate is also very important point when you are making activated carbon. How fast the heating is going on, okay, or how slow it is. So the surface area also depend upon this rate of heating. And then the impregnation ratio of the biomass to the orthophosphoric acid was 1:4 ratio, and that was mechanically stirred for 20 hours. And then what we found, the yield of that material from biomass to activated carbon was around 30 to 35%. So this is showing the photograph of this, just like activated carbon in the petri dish. So after making this activated carbon, the most important thing is required is the surface area. What is the surface area? As we know, there is a BT surface area measurement technique is there, in which we measure the surface area that's coming around 1852 meters square per gram. So very high number. Okay. So when your surface area is very high, that there are a large number of pores are there. That means it can absorb or adsorb the toxic element on that can help in the purification. Not only the surface area, another thing is what are the pore size. Pore size is also very important. You see this photograph, okay, the pore volume versus pore size. You can see when the pore diameter, according to the pore diameter, we can divide this as mesoporous material, microporous material, or macroporous material. If the pore size is 2 to 50 nanometer, we can say it's a mesoporous. It's smaller than 2 nanometer, we can say it's a microporous material. It's larger than 50 nanometer, then can a macroporous material. So you can see here most of the pores are lying between 2 to 50 nanometer. This is average pore diameter of 4 to 4.15 nanometer. So what we see, so that's basically a mesoporous material which having a surface area of 1852 meters per gram, and it can average pore diameter by 4.15 nanometer. So that material was the further used as a for the dye removal, and the other characteristic is basically you can see the SEM and EDX analysis of this activated carbon. This is basically the spherical particle and then agglomerated together. So this is showing some kind of a SEM, and EDX showing the carbon, oxygen, and phosphorus, which basically you are using orthophosphoric acid. Okay. Now we need to study some kind of kinetics. What exactly is happening when using this kind of activated carbon. Okay, so first the effect of pH as well as pH, PZC is very important parameter to study this kinetics for the adsorption. So you can see what we are taking. There are two graphs. When the pH is less than pH, PZC. Okay, so the adsorbent surface is positive and it attracts most of the anions. Okay, so you see there's a graph A. There are two materials. So in which the volume of HNO3, so we change the pH value, and then by adding some kind of nitric acid or titration study was carried out without using the adsorbent and with the adsorbent. So where these two graph matches, that point is called pH-PZC. So that is around 3.18. You can say the pH is higher than pH-PZC, the adsorbent surface is negative, is more attracting the cations. So you can see accordingly, we did some kinds of a study on the removal of dye. How we remove the dye? Basically, we make a solution of the dye, and then we can measure with the help of UV. What is you have a methylene. Here we are talking about two dye. Okay, we study two dye. One is called methylene blue, and another is eosine yellow. Okay, so we study with the help of the two dye. You have methylene blue. You put into the water, making some solution of different ppm, 8 ppm, 25 ppm, 50 ppm, and then we can take a UV spectra of that. In the case of methylene blue, you will get some kind of a spectra with having some kind of wavelength. Okay, in that wavelength there will be some kind of intensity. At the study of 8 ppm, when you are purifying with the help of adsorbent, that adsorbent intensity will get down. How much get down? Accordingly, you can get the percentage removal of that. Okay, so this is Ci minus Cf by Ci into 100. So you can get the calculation with the how much amount of dye has been removed with the help of a UV. Okay, so when we see what is the effect of pH on the removal of dye, you can see when the pH is 5.5 to 6, the most number of dye has been removed. Okay, so it's showing this pH value 5.5 to 6. That means it's a neutral in the range. So the other study which has been carried out only in the neutral, no other pH has not been changed. Then some study with the effect of adsorbent dosage was carried out. You can see what is happening. In which adsorbent dosage means we make a different size of dose. Adsorbent is activated carbon here. You add the 5 milligram to 20 ml to the 50 milligram to 20 ml, and then we draw some the percentage removal of dye with a different dye concentration of 8 ppm, 25 ppm, or 50 ppm. So you can see what is happening when the adsorption dose is increasing up to certain level. Then 1.25 gram of a liter adsorbent dose remove around 90% of methylene blue. You see from this first graph. So that means you need 1.25 gram of a per liter adsorbent, okay, to remove 90% of methylene blue. So not going too much of detail. Then we did some kind of kinetic study. What are these kinetic studies? Kinetic study, how this is the first order reaction or the second order reaction, pseudo second order reaction. So we have to go with the when we fit it in the different dimensions, then we found that the pseudo second order model basically is fitting well. So that means it's depending upon the both adsorbent as well as adsorbate. Okay, because it's a reaction. There's no reaction. It's basically physioabsorption process. What is happening? They have adsorbent and they dye. So dye is basically coming onto the place of adsorbent pore sides. Okay, so that's why it's a pseudo second order reaction. And then you see what is happening exactly. If we talk about 8 ppm solution, in the 8 ppm solution, 90% of the dye is removed and taking around the 5 hour. Okay, time. 300 minutes means 5 hour in the removing the dye from 90%, it's taking the 5 hour. So 90% dye को remove करने में 5 घंटे लग रहे हैं in the case of methylene blue. Another dye is the Yosun yellow. Okay, Yosun yellow E by that is only removing 65%. Okay, and taking the 5 hours. So for that, up further, there is another important point in case of adsorption. There are some kind of adsorption isotherms. Okay, that different kinds of isotherm, but how the interaction is taking place. That's basically talk about the Langmuir isotherm, Trondheim isotherm, DR isotherm. So in our experiment, we found that it's a well suited with the Langmuir isotherm. So that's basically a physio adsorption, and some kind of we found a DR isotherm. So these are the isotherm. You can see it's the best fitted with the Langmuir isotherm. Okay, in both the cases, either in the methylene blue or the Yosun yellow. So from that, what we exactly found with this study, when we are having the activated carbon, based on the eucalyptus bark, you have approximately 90% of methylene blue was removed, but it took 5 hours. Okay. In case of Yosun yellow, it's basically only 65% was removed and took around 5 hours. 5 घंटे में 90% methylene blue remove हुई और 65% Yosun yellow. So now there further scope how to improve this performance in the terms of percentage of dye removal or to reduce the time. So activated carbon, what we got by the using eucalyptus barks are good, having high surface area. For this purpose, it can be applicable, but you have to further improve their performance. So you see, there is another material called carbon nanotubes. It's a very fascinating material nowadays. It's a high aspect ratio, high surface area. It's a lightweight. So that can also be an alternate to utilize as a dye removal. But as such, carbon nanotube is basically hydrophobic in nature. So when you put it to the water, that is nothing is happening. Okay. So we tried making the combination with the activated carbon and the carbon nanotubes. Okay. So and this is our facility in the National Physical Laboratory, which we are producing the in-house carbon nanotube by using chemical vapor deposition CVD technique. So what we did basically, initially in some experiment, we take the eucalyptus bark and then mix the carbon nanotube simply and then use it. But it was not successful. It was not enhancing any property. So because there are two different phases, okay, somewhere there is carbon nanotube, somewhere the activated carbon, not properly mixed. So in that experiment, what we did, we have a eucalyptus bark, and then you put the bark, and same time you are putting the acid as a activation agent. At the same time, you are also adding the carbon nanotube, and then you're mixing. Now you have a material of carbon nanotube, eucalyptus bark, and the acid. That material has to be activated in the carbonization furnace. Okay. So when the activation reaction is taking place, the same all three things are available. So when the activation is taking place, the carbon nanotube as well as eucalyptus bark, the interaction is taking place, making the better possibility of improvement in the performance in terms of a percentage removal or in the time reduction in the time. After making that material, this is basically carbon nanotube incorporated activated carbon, which is made with the eucalyptus bark. Then we measure their BET and pore side distribution. So BET surface area was reduced. Okay, you can see what is happening is the surface area is only 101 meters square per gram. Earlier it was 1800 meters square per gram. So and then the total pore diameter was 2.34 nanometer. So as I talking about that, not only the surface area, some other parameter also plays important role. One is the pore diameter. Here the pore diameter was around 4 nanometer, and here the pore diameter is only 2.34 nanometer. When we measure the diameters of dye, okay, the methylene blue diameter is around 1.1, okay, nanometer, and the Yosun yellow having around 1.6 nanometer. So when both the dye having a diameter in some kind of 1 to 2 nanometer, so if the pore diameter is close to the 2 nanometer, then it will be better. Once the dye is interacted into that of a pores, that will not come out. So better proficiency will also be helpful. So here, this is the pore size diameter. That's why the average pore diameter about 2.34 nanometer. It's also mesoporous material having a 2.3 nanometer. And then this is carbon nanotube.
Can you conclude next 5 minutes? Sir?
5 minutes, yeah. Okay,
thank you.
Then similarly, you can see its effect with the PZSC was also taken similar way. And then we found that, not going too much of the kinetic details, then we found it's taking around 30 minutes only to remove that 90% of dye. Okay, so 90% of dye was removed only in the 30 minutes. Earlier, it's taking about the 5 hours. So by using the carbon nanotube, it's helpful to remove the dye in the efficient way. And then this also having the second order, okay, pseudo second order reaction which fitting with that. So 1.5 gram per liter of methylene blue and 0.5 gram per liter of using yellow adjuvant was used. Okay. And then it's basically was fitted with the DR isotherm. Okay. And then we also characterize the material after dye incorporation. What is happening is the dye has been adsorbed or not. You can see this by the help of Raman spectra. And then you see the Raman spectra, there is a pure, before adsorption, there are pure carbon materials, which are having a D band or G band. And then this is the spectra of methylene blue. So after the adsorption of a dye, you can see some other peaks has also been found. So that means the dye has been also be adsorbed on the surface of activated carbon. And then we see this is the proposed mechanism. The methylene blue after 30 minutes, this has been color has been fully changed. Or similarly in the USN yellow, that has been changed. So more than 90% of methylene blue and USN yellow have removed within the 30 minutes. Okay, and equilibrium almost achieved in the 1 hour. After that, what we try to do, initially the carbon nanotube is not a functionalized, because but if it's not functionalized, when you're producing these carbon nanotubes, a big bundles form. So the bundle means if the individual carbon nanotube will not be incorporated, the property will not be enhanced. When you're having the functionalization of carbon nanotube, the individual carbon nanotube will be there, so that the property can be further enhanced. So accordingly, what we found, the similar process was followed, only the carbon nanotube was replaced with the functionalized carbon nanotube. Then surface area was also enhanced, that was between of the pure activated carbon and the carbon nanotubes. It's around 700. And then pore size are further reduced to 2.2, but very close to the diameter of both the dyes. Then we found this study. Okay, so this shows only around the 15 minutes we can remove the dye in 90% of methylene blue and USN yellow. 15 minutes. Earlier we were taking the 5 hour, then it's reduced to 1 hour, then it's to go to 30 minutes. Or equilibrium reached to 30 minutes, so we can reduce the dye only in the 15 minutes by using this functionalized carbon nanotube incorporated activated carbon, which is formed from the eucalyptus bark. This is a summary of these results, which has been lowered only taking of the 300 minutes for the whole equilibrium, the 60 minutes and only the 30 minutes, but 90% has been removed only in the 15 minutes. It's a very interesting with the helping the incorporation of the carbon nanotube in the activated carbon. But this is only in the powder form. I will take only 1 more minute. Okay, so it's going to conclusion. This is basically the carbon nanotube incorporate activated carbon just like in powder form. As I talked about, this is hydrophobic in nature. Okay, so you need to some kind of material. Also, when you put this material into any of the purification, regeneration is also very difficult. It's a powder. How will remove and then again use it? So, and few other experiments we are trying nowadays to make it which can be regenerated. So it can once use it and then regenerate it, and again we can use it. So for that, we have a facility in our NPL. We are making the carbon nanotube paper. This is just like a sheet by using only the carbon nanotube. So we are trying to utilize this carbon nanotube sheet as a good adsorbing material for removal of these kind of dye. So few experiments which we found that these are some kind of because when you're making this kind of paper, they use some kind of surfactants. This is hydrophilic in nature, so that is useful. That's why to put this carbon nanotube sheet into the dye solution that can adsorb most amount of our dye. So some initial experiments say that we can improve or we can remove around the 99% of the dye by using this kind of carbon nanotube paper. Once you put it, this carbon nanotube paper, you see, and then after that there is no dye. Color is there. So the most of the dye had been adsorbed on the surface of this carbon nanotube paper. So 99.6% of dye was removed of the example of the 8 ppm solution. So now, but we are trying to do, we are also doing some kind of a study how much time it is required to remove such kind of dye in the very significant way. So thank you very much. These are acknowledgements for my students who are working on this. Shailesh Kumar Yadav, Mamta, Manoj, and Ananya, who worked on this project. Okay. Yes.
I'm asking not about university. So you have taken eucalyptus tree. So the water, wherever there is just take this one. Just take the camera. Okay, fine. Very good talk, sir. So my question is like in presence of an environmental botanist here. So I'm asking this question like the water, eucalyptus tree, acacia tree, these trees are affecting the water availability of a place. Like wherever these trees are there, it will affect the water availability or water cycle of that particular place. So is that the criteria you have, because it can absorb more water? The absorption, the absorption capacity of these bark is very well known. Is that the criteria you have taken this bark, eucalyptus bark, and if possible, we can is it possible to compare with acacia or any other trees with such good water uptake? And one more question is after the dye uptake, you are anyway you are dye removal, is it possible to characterize or is it possible to what I'm trying to say is like is it possible to recover those material from the final that nanomaterial?
That's why I'm talking about.
Yeah.
Last part of the talk with that. When you are using the, I will just answer the first question. Okay. You can also compare with the other kind of tree. Okay. When you talk about activated carbon, more commonly made activated carbon is basically based on, in the Kerala, what are the trees there? Coconut cell. Okay. The coconut cell based activated carbon is globally used. Okay. Just because it's very hard in nature. So you can try several type of biomass. The thing is, where you are making the biomass, the availability of that raw material, that's why the activated carbon are made. Whatever the availability of the raw material, that's why the studies are carried out. So more common is basically the coconut cell. If you talk about the north side, the people are making this kind of activated carbon with the wood type of material. So you in the Haryana, Punjab, I have seen few companies, they are making with the wood. The availability of the raw material. Basically, what is the activated carbon or carbon? You have any kind of biomass, you burn it, you convert it to the carbon in some kind of a control environment. So it basically depends upon what is the availability of the raw material in that location. So because the cost also very much dependent on the activated carbon of the what is the raw material of that. So basically that's why otherwise you have to only play with this kind of parameter. What are the parameter? The concentration of the acid. You have to 1:4 ratio. You have to go to 1:5 or 1:3. What is the temperature? It depends upon the what kind of biomass is there. So it is possible you can make the carbon activated come from other kind of a tree, bark, anything. It's a you burn the any man, you can convert into the activated carbon. Okay, वो किसी को जलाओगे carbon बनेगा. उसको nothing change. The only thing you have to play with the parameters, so you can make it. Thing is, second part, your question was. मैं भूल गया.
I work on membranes. Can we?
No, I remember. Yes. Second part is basically you are saying when you are taking this activated carbon, it put into the dye solution. So it is very difficult to recover it again. That's why I'm trying to make this kind of sheet. You see the carbon nanotube sheets. You put the sheet into the beaker and then all the dye will absorb on that sheet and then you can regenerate it, further you can use it. So it's easy to take it out. Sometimes you can have a big tank of that and outside of tank you can make some kind of roll of the carbon nanotube paper. Okay. So all the dye can be absorbed on the substrate and you can remove that and again put it. So this is possibility of regeneration. So these further regeneration studies have to be carried out on that material. So hopefully it will be possible. Yes, sir.
So basically the barks, they have like lots and lots of polymers which are nitrogen containing and carbon containing. So when you're forming the okay. So my question is like the barks, they have any tree bark, it has a lot of nitrogen containing polymers like lignin, we have chitosan, different varieties. So when we are actually doing the carbonification of any nitrogen containing polymer, we are supposed to get like a carbon framework which contains the nitrogen. So don't you think that doping the carbon framework with heteroatoms will benefit in the
Yes.
diabsorption?
Hopefully, most of the time, when you talk about other kind of application, people are doping with the nitrogen, especially in the energy storage. You see the superchemist, lithium-ion battery, the people are trying to dope with the nitrogen. It can improve their electrochemistry. Similarly, in the dye cases, there is a chances if they are doping with the nitrogen can be done, then hopefully they can further improve the performance. Yes. Okay. Okay. Okay.
Thank you, sir, for such an informative session. Now we would like to introduce Dr. G. Bharat. Dr. G. Bharat is an assistant professor at the Department of Environmental Studies, University of Delhi. He has a PhD from CSIR, Indian Institute of Chemical Technology, and was a postdoctoral researcher at Ariel University, Israel. He has received numerous awards and recognition for his contributions to the field of environmental studies and biotechnology, including the CSIR Technology Award in 2021, PBC Fellowship under the Outstanding Postdoctoral Researchers category by Israel government, and the Most Innovative Energy Saving Product 2017. He has also received funding from DAD, Germany, TWAS, and DST, Government of India, for his research work. Dr. Bharat has presented research papers at various international conferences and received multiple Best Paper awards. Over to you, sir.
Prashant, thank you to the organizers and welcome to the students also for hearing this lecture. Red one. Okay. Yes. Yeah, today I'm going to deliver the lecture on the how nano catalysts playing the role, especially in the bioproduction production processes. So this is the lecture I'm going to do. Before going to enter into the main basic concept, first we will see what is the necessity of the renewable energies. Yes, here, yeah, nowadays we all are looking for the, all people are talking about the renewable energy sources. So, because fossil fuels resources are day by day, it is decreasing. And here you can see in this graph, at present, most of the 80% of the world energy source is the fossil fuels. But by 2050, renewable energy is going to the main predominant energy sources, that is the 28%. And what are the energy sources? We all know renewable energy sources and non-renewable energy sources. So in the, especially in the renewable energy sources, those are solar, wind, biomass, and geothermal energies. And what are the pros and cons of these renewable energies? So first one is that it is advantage, it won't run out. So it is a sustainable approach and numerous health benefits also. And it is, again, we need not to depend on the foreign resources, especially at present we are importing a lot of the fossil fuels from the different countries. So again, in this also we have some different some disadvantages, like it is intermittent. It is mainly based on upon that seasonally based, especially solar and solar renewable energy sources, and need for energy storage, it is a big concern, and geographical limitations again. But for the tropical region, solar energy is very good one, and but like that in the case of non-tropical regions, again it is a vice versa. So now let's see what are the biofuels. Biofuels, it is a nothing but how we are producing. Means generally we are produce the biofuels from the biomass. Here you can see the some of the biofuels. Examples are bioethanol, biodiesel, biogas, and biohydrogen. And what are the advantages? In generally, whenever we produce the biofuels, and whenever it is going to combustion, it will generate the less carbon emissions compared to the fossil fuel emissions. And here you can see what are the biomass sources. Those are the might be plant debris, animal waste, and food waste and wastewater. All these waste material generally considered as the biomass. So here generally will use the different process for the production of the biofuels. Those are the anaerobic digestion process, microbial fuel cells process, combustion, pyrolysis, etc. And here you can see the biomass, how we are going to generate in general biomass to our biofuel and bioproducts. In the first of all, the biomass, it is a mainly sustainable approach. What is the sustainability? So we need to meet the present generations, and it should be available in the future generations. So that is the main concern, and that is the advantage of the biofuels. And after that, again, in generally, biomass contains a lot of the cellulose and hemicellulose. Accordingly, research is going on to how we are going to hydrolysis those parts. And finally, by using the different microorganisms and different enzymes, we will generate our desired biofuel. And these are some of the characteristics of the biofuels, like non-toxic, sustainable. These are considered the carbon neutral. And here you can see the biofuel energy production. In the top 3 countries are United States, Brazil, and China. At present, in the United States is generating nearly 400 terawatt hour energy generation, and Brazil is generating nearly 250 terawatt hour energy generation. In China and Germany, India subsequently is generating. Here in India, we are generating only 50 terawatt hour energy. So why we are talking? So what is the necessity of the renewable energy sources? So what is the necessity? Yes, first of all, sustainable developments might be you heard this. As previously we have Millennium Development Goals, especially now the 2015 to 30. We are working on the sustainable development. In that, one of these total 17 sustainable development goals are present. In this 7th goal is the clean energy and sustainable energy production. And based on that, again, United Nations also with that time they are giving a lot of implementations and all over the giving a lot of policies and giving the guiding all the countries. So here in the last year, our PM Narendra Modi gave a lot of pledges to reach the renewable energy sources. In that meeting, our Prime Minister made a promise that we are going to make the net zero emission target by 2070. And by that, to reach the target by 2030, we should generate the 50% of the renewable energy sources, and simultaneously we need to reduce the 1 billion tons of the CO2 emissions. Again, why we need to reduce the CO2 emissions? Here we are generating nearly, here you can see the top 4 countries, CO2 emission countries. India is the 4th top country in that one. So that is the reason we have a lot of promises in that one. Again, not only India, all over the world, countries are pledges so many things. Like the China promised their country is going to the net zero by 2060, and European Union and United States promised that they are going to net zero by 2050. So based on those policies, Indian government also made some policies. One is the national policy on the biofuels, that is 2018. In this policy, government has made that 20% of bioethanol is going to blend with the petroleum, and 5% of the biodiesel going to blend in the diesel by the 2025. By 2025, previously its targets are 2030, but after that to reach these goals very fast, and this is reduced to under 5 years. Again, for to generate the bioethanol, especially in this regard, nearly 5,000 crores for the research development and infrastructure development the government has giving for that one. Again, previously we have generated the bioethanol only from the sweet corn, that is the only source. But at present we are generating, government has given some permissions, so it's possible, especially waste food grains, especially Food Corporation of India, they are making lot of waste, lot of food waste they are generating. So based on price, government has approval to generate the bioethanol. And again, it is another mission, that is the production of the biohydrogen production. In this biohydrogen production, again, not biohydrogen, national green hydrogen mission. In this, mainly it is government. Again, hydrogens are different types, as blue hydrogen, gray hydrogen production, and green hydrogen production. In this green hydrogen, mainly it is works on the based on the electrolysis process. In this electrolysis process, one of the part is the microbial electrolysis. For this one, government has uh, given for nearly 19,000 crores for the research and development and infrastructure development. So all this, so government is working very hard to reach those goals by 2030 and by 2070 to meet the net zero emissions. Based on that, government has made so many policies. One is the Pradhan Mantri Jaivan Yojana to generate the 2G ethanol from the different crops, and in that surplus rice to ethanol they have granted, and another to produce the biodiesel. Now they are permitted to use the reused cooking oil, especially they are collecting from the oil from the restaurants. They are trying to generate the biodiesel, and another policy is for the co-firing the biomass, especially in the thermal plants. Co-firing, it is a mandatory rule. We should use 5% of the biomass in the thermal power plants. And based on that, another policies, waste to energy programs and biomass programs also government has made for that one, especially allotted 858 crores. And this is the biogas. Again, in addition to those policies, again, biogas programs, in this government has given some new national biogas and organic manure program to increase the biofertilizers availability to the farmers. And Govardhan scheme. All these schemes are schemes, and main policies, main aim is to increase the renewable energies, especially biomass, biofuels, and the availability of these compost or biofertilizer to the farmers. So now let's see what are that is the why renewable energy sources are very important. Especially in this, I am going to talking about the biofuels. So these are different types of biofuels. One is the biohydrogen. We all know that is, again, this is the process mechanism involved in this one, that is the mainly involved biohydrogen production process is the fermentation, especially estrogenic fermentation process and photofermentation process and microbial electrolysis process. These are the three mechanisms involved in the biohydrogen production process. And the second one is the bioethanol production process. In this, again, biomass is the main ingredient in this any biological process. After that, by using the enzymes, especially hydrolysis process, we'll use different types of microorganisms, enzymes, that is generally we'll call it the saccharification process. After that, by using the fermentation, especially we'll use the yeast, that is the Saccharomyces cerevisiae. Finally, we will generate the bioethanol. By using the distillation process, we'll separate this bioethanol and biodiesel. Again, previously we have used Jatropha plants for the generation of to extract the biodiesel, but at present we are all the at present government is looking the reused cooking oil and vegetable oils and animal fatty acids. These are the main source. Again, from that one, by using the trans-esterification process, finally we will generate the biodiesel. And biogas. In this biogas, it is a mixture of the methane, CO2, ammonia, and H2S gas. Again, this is the biochemical process of the production of the biomethane. Here, these are the four different types, different steps involved in the generation of the biomass. Those are the hydrolysis, estrogenesis, and methanogenesis. So, in this process, especially in the biomass conversion process, in the hydrolysis process, generally we'll go for the pre-treatment by using that is the hydrolysis, by using the different pre-treatment technology. Those are the acidic or basic catalyst, acidic technology, acidic catalyst, and enzyme catalyst. Yes, this is a very complex chemical reaction is happen whenever we are going to generate, especially methane in the anaerobic digestion. Biomass is going to convert different volatile fatty acids like acetic acid, propylenic acid, butyric acid. Finally, in the next step, it is going to generate the methane by using the acetic acid and hydrogen and CO2. So in this, whenever this reaction is going to happen, so in this reaction, lot of electrons going to involve. So how is the electrons is transferred from the one bacteria to another bacteria? It is a very critical point to the yield of the any yield. A very critical point for the production of the biofuel. So these are two mechanisms involved in this one. One is the mediated electron transfer mechanism, and second one the direct mediated electron transfer mechanism. In the indirected mediated transfer mechanism, in this especially hydrogen format is involved. In the another one is the direct mediated electron transfer mechanism. In this mainly microorganisms, pili and conductive materials are going to involve. It is the diet mechanism. Again, what is the why it is a diet mechanism is very important, especially whenever the in the any anaerobic reactor mainly hydrogen and format is present, but again it will change based on the anaerobic conditions, so it is not always available. So that's why people are looking for the diet mechanism. There are the four methods are available, again by using the pili, especially nanovites. Yes, here you can see that this is the mechanisms involved in the electron transfer one bacteria to another one. Here, one other mechanism that by using the pili. Previously, all the scientists thought only conductive pili only for the conjugation and only for the attachment. But in the year of 2012, these pili, especially geobacteria and deosulfovibrio bacteria, they are working as a nanovites to transfer the electrons from one place to another. And other mechanisms are electron transport by using the cytochromes and finally conductivity. So based on this data, nanovites by using conductivity, so research are moving. So why should not try we using the conductive material? So based on that research, people are trying using different conductive nanoparticles and nanocatalysts. So for the enhance the electron transfer from one bacteria to the from one bacteria to the another bacteria. So here these are the three types of generally nanocatalysts are available. One is the zero valent metal nanoparticles and metal oxide nanoparticles and carbon based nanoparticles. Zero valent metal nanoparticles are nickel, cobalt, copper. These are some of the examples. Mainly these zero valent metal nanoparticles, especially useful in the hydrogenotrophic pathway. Again, in the case of anaerobic digestion, these are two pathways are present. One is the histoclastic pathway, second one is the hydrogenotrophic pathway. In the histoclastic pathway, mainly it is going to convert the methane. In the hydrogenotrophic pathway, it is a hydrogen plus CO2 is going to convert to the methane. So especially the zero valent metal nano particle is working on the hydrogenotrophic pathway. So again, these zero valent metal nanoparticles is decreasing the hydrogen sulfide concentration in the anaerobic digestion. In general, hydrogen sulfide have a corrosive nature. So that's why whenever we have used the especially iron, these hydrogen sulfide going to react with the iron, it is going to form ferrous sulfide. So hydrogen sulfide is formation is very less. So like that, we will possibility to remove hydrogen sulfide in the biogas. And another one is the metal oxide nanoparticles. These are some of the example: titanium, manganese, nickel, zinc, ferrous, copper oxides. All these oxides is generally considered the metal oxides. Again, these metal oxides are preconditioned enzymes, and especially these metal oxides works as a cofactors for the natural reactions occurring in the anaerobic digestions. Especially zinc and cobalt plays very crucial role in the transesterification factors in the enzymes, and especially copper is the fundamental factor for the biological electron transport as a coenzyme. And then nanoparticles are carbon based nanoparticles. These are the again different types: graphene, graphite, fullerenes, multi-walled carbon nanotubes, and single-wall nanotubes and nanofibers. These are some of the examples of the carbon nanotubes. Again, these carbon nanotubes also working towards the increment of the biogas production process. This is the application of the conductive nanoparticles. Whenever we add the conductive nanoparticles by using the zero valent metal oxides and carbon based nanoparticles, it is transferring the electrons from the oxidizing bacteria to the methanogenic bacteria. So like that, here CO2 is going to convert to methane. This is the reason we are adding these nanoparticles. So what is the role of the nanoparticle? It should be it is mainly hydrolysis going to happen. That is the one, and it is promote the process reactions, and every nanoparticle should have some basic characters like it should be non-hazardous, chemically stable, inexpensive, recyclable, and higher surface area. Now let's see some of the studies how the nano catalyst is influencing the biofuel production processes. In this is study basically for the generation of the biomethane with the graphene nanoparticle. In this study, they have taken different types of the graphene with the different concentration, like 0.5, 1, 2, and another one is the activated charcoal. So the different in this study, they found that the concentration of the 1 gram per liter reactor is they are generating the nearly 25% of more biomethane is they are presenting in this study. Again, in this with the compared with to the control. And this is the main conclusion from this, why it is going to improving this concentration 20%. Means it is mainly whenever we are adding, especially this graphene concentration, is microbial aggregates are forming in the anaerobic digestion reactor. Whenever the microbial aggregates are going to happen, it is electrons are easily transferring from one place to the another place, one bacteria to another bacteria. So that is the reason. That is the reason biomethane concentration is increasing 20%. Again, after in this study, again you can see it is only effective 1 gram of graphene only. If we have taken 2 grams of graphene, again it is reducing or no effect on the biogas enhanced capacity. So like that is the one study. Here you can see the another study. Here the people have taken carbon nanomaterials as the catalyst for the, here they have taken again sheep manure as the main substrate to generate the biomass. Again, in this study, what they have observed, again different carbon nanotubes they have taken, especially multi-wall nanotubes they have taken, again with the higher concentration, especially 500 milligrams of the carbon nanotubes per kg of the substrate, they have generated a higher amount of the biogas. Again, why it is increasing the biomethane production in this whenever we are using the carbon nanotubes, it is mainly reason of the methanobacterium. Whenever we are adding this bacterium, it is mainly methanobacterium aggregates are forming in this anaerobic reactor. It means the diversity, especially this methanobacterium is the main, especially this methanobacterium is involved in the conversion of the acetic acid to methane gas. So that is the reason biogas is increasing. Again, another study, anaerobic digestion of the chicken manure. In this, they have taken carbon nanotubes in the different concentration. With the concentration 0.5, 2, and 5 grams. Again, here with the higher concentration with the carbon nanotubes, so that is the 5 grams per liter, they are giving nearly 16% increment in their production. Again, why it is, again in this study, why it is again gas production is again diet mechanism is happening irrespective of the hydrogen format. So that is the advantage of this type of conductive materials. Again, this is related to biohydrogen production. In this study, people are taken nearly nickel. First of all, they have studied with the nickel nanoparticles. With the nickel nanoparticles, they are producing nearly cumulative hydrogen production in the 40 ml. In the case of control, it is producing only 30 ml. Again, it is the cumulative hydrogen production 40 ml with the only 60 milligrams of the nickel only. If you have taken 100 milligrams of the nickel in the 1 liter of reactor, it is not affecting of the enhancing the biogas production process. So here again, here in this study, it is again nickel graphene nanocomposite study. Again, whenever we are composite nickel and graphene, it is showing again 60 ml of the cumulative hydrogen production. So it is again with the concentration of the 60 milligrams per liter. Again, with the 100 milligrams per liter, is no effect on the efficiency of the reactor. Again, so it shows that nearly nickel and graphene nanoparticles is highly effectively enhancing the reactor nearly 105%.
Dr. Bharat, can we conclude now?
Yes.
Yeah.
Okay, sir.
Yeah, within 5 minutes. Yeah.
Yes, sir. So again, these are some of the bioethanol production. In this also, they have taken nickel oxide nanoparticles. Again, it is increasing the bioethanol production process. Especially in this study, we have taken Saccharomyces cerevisiae as the main yeast strain, and by using the potato peel, their their production rate is increasing. So these are the some of the studies we've as researchers found. Again, these are the related to. So in the overall here, you can see the especially zinc oxide nanoparticles are more highly toxic to the especially E. coli, and copper oxide nanoparticle effect decrease the methanogenic bacteria. Titanium oxide nanoparticles and adverse effect on the especially acidogenesis and methanogenesis, and zinc oxide, copper oxide, all the magnesium and manganese oxides are again showing the negative affecting on the biogas production rate. So it means all the nanoparticles is not is useful for the production of the biogas. Only some of the nanoparticles are very helpful during this process. Again, let's see some of the challenges. So up to now, all this work is going in the laboratory scale, but what is the availability? So in the case of laboratory scale, for the 1 liter reactor, we are adding nearly 500 milligrams of the carbon nanotubes. But in the case of commercial scales, especially anaerobic digester reactors, generally we will use the daily we will use 50 tons of substrate daily. We'll use our 100 tons based on the availability of the substrate. For example, in this Noida, in the sector 123, and it is going to construct one anaerobic digester with the 50 tons capacity. If we were for that project, I am also one of the consultants for that one. So in this actually we thought to have the nanoparticles, but in the practical purpose it's not happening because it's a cost, it's availability. One reason cost is very in the laboratory. Whenever we have studied, whenever you purchase from the vendor, it is 1 gram of the carbon nanotube cost is nearly 1000 like that. So it is not possible to implement that much cost. We need to spend daily 25,000 in the case of we will use the 50 tons of substrate every day. So this is the disadvantage of these nanoparticles. Again, what is the environmental impact, especially whenever we use the metal nanoparticles? Again, so first of all, after in general, the anaerobic digestion process, after the digestate, we will that material, that digestate, we will use as the biofertilizer. But whenever we will use these nanoparticles, especially metal nanoparticles, so whenever we are going to use these fertilizers for the plants, after that we will from that we will extract the plants and vegetables and we will take it. So we need to study how it is going, nanoparticles moving from one place to another. What is the impact, environmental impact and human impact? These studies are lacking up to now. And again, is commercial scale, it is especially should be cost is very less. That is the one thing. And any again toxic effects we need to study to implement any nanoparticles in the biogas or any biofuel production studies. Thank you very much for giving this opportunity.
Any questions, please, audience?
Thank you so much, sir, for your informative session. Now we request Dr. Amit C. Kharakwal to present the mementos to our esteemed speakers. We request Dr. Amit C. Kharakwal to present the memento to Dr. Prasoon Kumar Roy. We request Dr. Amit C. Kharakwal to present the memento to Dr. Bhanu Pratap Singh.
We request Dr. Kharakwal to present the memento to Dr. G. Bharat. Now, I would like to invite Dr. Sangeeta Tiwari ma'am to present the memento to Dr. Amit C. Kharakwal. With this, we conclude our technical session 3. Everyone, please proceed for lunch, and we will start our technical session 4 at 2 o'clock in C Block Auditorium. All are requested to be please here by 2 o'clock. Thank you.
The registered students will proceed to the foyer for the lunch. All those who are presenting the poster, please make sure that you have displayed your posters in the room during this break. And all the faculties and guests, please proceed to LG03.
We are inviting Dr. Roy and Professor Tiwari to please come on the stage. Hello. Before we proceed to session, we request Dr. Prasoon Kumar Roy and Professor Sangeeta Tiwari ma'am to present saplings to Dr. Vijay Kumar. Sir, please come on the dais, please. Thank you so much, sir, ma'am. Now I would like to hand over the session to the session chair, Dr. Sangeeta Tiwari ma'am.
A very good afternoon to all the delegates. And students, please come forward. Those who are sitting at the back, please come forward. So we are going to start this technical session, which is the last session of this conference. And the first speaker is Dr. Vijay Kumar, whom sir will introduce.
Yeah. It's indeed a pleasure to welcome Dr. Vijay Kumar. Dr. Vijay Kumar Sharma is working as a principal scientist and associated with internal biosciences since September 2008. Prior to IBS, he has worked in many premium segment pharmaceutical organizations such as Jubilant and Ranbaxy Research Labs, presently Sun Pharma. He obtained his PhD from Amity University, Noida, in medicinal chemistry and his master's in applied chemistry from Guru Nanak Dev University, Amritsar, Punjab. So he has extensive experience in the field of heterocyclic compounds from milligram level to kilogram scale. So I welcome him, and let's hear from you, sir.
Yeah, good afternoon, all of you. And it is my privilege to present some work on behalf of Amity University and on behalf of Integral Biosciences. First of all, I would like to thank all esteemed guests and Professor Sunita Ratan ma'am and Christine ma'am to give me opportunity to share my research work, or you can say research experience, over this dais. And while I got this invitation from Christine ma'am, I thought basically what to present and what not to present, because I need to balance my presentation between academic students versus researchers. So I have tried to put a balance. I believe that this presentation will give you information about medicinal chemistry process, how we go through the medicinal chemistry process, and I will try to explain this by some case studies from my research work. And I hope you all will enjoy and learn uh, and take interest in medicinal chemistry in future as a career for especially for students. So let us start. Actually, my today's talk is on an insight into the drug design and versatile synthesis process development for TZD is basically thiazolidinone and quinazolone derivatives. So agenda for my presentation will be, I will give some overview basically about the drug development pathway, and then I will show you how we develop some TZD derivatives. Then I will explain to some extent the synthesis strategy which we utilize to make those proposed molecules, and finally conclusions. So moving ahead, if you see the overview for a drug development pathway, there is a lot of number of years, around 13 years to make a drug in the market, and lot of efforts are there. If you see 4 to 5 years will only take for in vitro and in vivo analysis, that includes basic research, early development, preclinical stage, and all that. Then if we got some active molecules, the target which we generally trying to put some efforts, then there is IND applications, and after that 6 to 7 years goes for clinical development, which includes phase 1, phase 2, and phase 3. And after that there is a NDA, new drug application that will require where FDA review, rigorous review about our drug mechanisms and all that, and that will take around 0.5 to 1 year. And finally post marketing monitoring is around 1 to 2 years, and that goes on through the whole cycle of your commercialization. So all in all for a new drug to get approved, it takes around 12 to 15 years and colossal sum of money, that is around 1 billion. And more or less it takes 13 years. It means 1/3 of your career goes to make a drug. And one more thing, 90% of drug candidates fails in clinical trials. This is a ground reality, and there is a lot of intellectual and physical teamwork is required to make a drug. So it is very costly to invest in this business, and industry supports followed by academia make it possible. If we don't have academic support, I think it can take 40 to 50 years to make a drug. So I will discuss a case study from my research work, that is development of glitazones, basically based derivatives. I will put some literature insight and how we think strategies for design, and then some docking scores based on Schrodinger's. So in this session, first of all, I would like to give some brief history of commercial glitazones. So basically the story begins from the sigitolizolone in 1982, and it has screened as a potential lipid lowering agent. Then later found to have unexplained glucose lowering effect, and finally it was abandoned in the market due to liver toxicity. So by the mid 90s, glitazones are shown to be in PPARs, and then in 1997 you can see the number of years, 15. After 15 years, troglitazone is launched in the UK and withdrawn from the market due to serious hepatotoxicity after 6 months. Now, after 2 years, in 1999, pioglitazone was launched in USA and used as a combination therapy. But its usage again decreased due to the side effects such as congestive heart failure, anemia, and increased risk of bladder cancer. Now again, later 1999, rosiglitazone was launched, and it was among the top 25 selling drugs for that year. And later it was developed as a combination therapy. but again its usage decreased due to increased risk of heart attack and death. And then in 2013, lovaglutazone was launched, and it is approved in Korea, and it can be used alone or in combination with metformin, and it brings more effective glycemic control in comparison to other drugs and has lesser side effects. And one of another which is for which research is going on, that is rivoglitazone. For this molecule, research is ongoing. So moving to our next part of presentation, that is structural changes in glitazone drug over the period. If you see the pioglitazone, that has pyridyl group followed by ethyl at the para position, then the structure of rosiglitazone is slightly changed towards this pyridyl N-methyl, and further in lovaglitazone there is pyrimidine followed by this para-phenoxy ring. So we thought of to make some changes, to make some novel compounds. So we from the literature we found that piperazine based glitazones were not reported, and another, the aliphatic chains was not explored on the pyrimidine ring. So then we move on to our crystal structure of PPAR gamma in complex with pioglitazone. That is a very detailed I cannot give detailed discussion about that, but yeah, I will give some overview about the crystal structures in complexation with pioglitazone and lovaglitazone. If you see the structure similarity between the pioglitazone and lovaglitazone, it is U-shaped in the complexation with PPAR gamma. And again, then you can see there is a hydrophobic pocket which is occupied less in case of pioglitazone, and there is a elongated paramethoxyphenol group occupies the hydrophobic pocket better than this pioglitazone. Another change is that TZD head group and PPR gamma LVD form hydrogen bond networks. You can see TZD head group of pioglitazone, PPR LVD form 2 hydrogen bonds, and similarly levoglitazone form 2 hydrogen bond with histidine 323 and this serine 289. Another interaction which is similar is carbonyl group of histidine 449. But in case of pioglitazine, you can see that glutamine 286 doesn't have any hydrogen bond interaction in comparison to lovaglitazone. That may be the reason for some high docking score over there, but this is random. So the overall binding mode of lovaglitazone is very similar to that of pioglitazone, except the elongated paramethoxyphenol group of lovaglitazone. And extra hydrogen bonding with glutamine 286 might be the reason that lipoglitazone is more efficacious than this pioglitazone. So based on that, we designed 2 series of compounds, and we have docking score for different molecules. But I cannot discuss all the crystal structure bonding for all the molecules. So I just take one example which has the highest docking score and comparable to this lovaglitazone and better than pioglitazone. I will discuss the interaction between them in the subsequent slides. And another series which we made aliphatic chain based thiaglitazone, keeping that chain fixed, and then diabotation was done on the pyrimidine position that has been mentioned as AR. So again, from this series, I will discuss the crystal binding about this TSPH2, which has minus 11.66 docking score. So you can see the bonding between the lovaglitazone, TSPP1 and TSPH is quite similar, and our designed molecule have all interaction in comparison to lovaglitazone and comparable docking score as well. And in fact, better than the previous commercial drug pioglitazone that has minus 11.60 docking score. So now, what is the path ahead after docking, designing? What is the path ahead in drug discovery? So if you see, docking allows predicting the preferred pose of a ligand inside a receptor binding site. So if designed molecule have all interactions and comparable docking score with commercial drugs, then we can move to synthesize them, and this is really a challenging one. So we need to do disconnection approach supported by literature, because in industry we don't have that much time to develop new methodology. So basically we quickly go to the disconnection approach, and we order the key starting material. This is actually the basic process for all the drug discovery projects, followed by this CAD, chemistry associated designing. So the aim is to synthesize the target molecule. Initially, the aim of industry is to synthesize the target molecule as quickly as possible, irrespective of route. You have to make molecule fast and do the in vitro assays or activity assays for lead optimization and identifications. And after lead identification, industry starts looking for cost-effective and scalable method. This is basically during preclinical or clinical development, because we need to commercialize. If we have to commercialize a drug, we need to make a process abundant, cost effective, and on larger scale. And finally, synthesis strategy utilized to make proposed molecule is discussed in subsequent slides, and I have tried to put insight on most aspects of synthesis, most of the aspects which we generally use in industry. So first of all, I take this synthesis strategy to make proposed molecule and put some literature insight. Up now, the shift is from your literature from drug point of view to synthesis point of view. So there is a huge literature present for synthesis as well. So if you see, the initial synthesis approach for synthesis of glitazone is substitution followed by reduction, then diazotization followed by this substitution, cyclization, and then reduction. So the first generations glitazones are generally made by condensation or nucleophilic substitution, nitro reduction that I have explained, diazotization, condensation with methyl acrylate, cycloaddition with thiourea, and then hydrolysis to give the glitazones. But there are some limitations on larger scales. Limitations are that we use a pyrophoric base like sodium hydride, and there is a cascade of reagents, intermediates like toxic acid, HBr, and diazonium chloride as well. So definitely we need industry need to develop some better methodology. And if you look at the literature, people has just take the thiazolidine ring with the aldehyde, done the novel condensation, and then reduce this to get all the glitazones of second generation or more. So all the glitazones are synthesized by this strategy on industrial scale. Now, for first aliphatic chain-based thiazolidinone derivatives, we opted for linear synthesis approach. So basically, to get our target molecule, we started with intermediate 1, and then protection with TBDMS, followed by substitution, then Suzuki coupling. We used homogeneous catalyst for Suzuki coupling, then deprotection followed by oxidation, and then this novel condensation and reduction with the PDC or some reducing agent, and we synthesize 9 compounds of this series. So during this scheme, we realized that for second series of compounds, basically we need some divergent type approach, because this is quite hard working, because you need to start molecule from step second to make all these molecules. And I will discuss that later, and put some light on controlled drug release. So we compared our designed molecules and commercial drug lobeglitazone, and we did a comparison, and basically the cumulative percentage release of this THP6 and this lobeglitazone is comparable. So we can also, this is still controlled drug release for lobeglitazone is not reported. So this can be worked further to get rid of side effects and all that from glitazones. So conclusions, we have developed a novel class of TZD based analogs, and synthetic strategy is linear, basically protection of hydroxyl and then substitution. Suzuki coupling at this stage is very facile and give good yield with all boronic acids. Steps involved in the synthesis are reproducible with high level of research activity, and we can make molecules, but yeah, synthesis is linear. So we have also tried some another approaches that I have not highlighted here because due to time constraints. And we can say that controlled drug release, if we compare with commercial drugs, although there is no data available, but yeah, that is comparable to our drug. So yeah, definitely we can further develop these. Now in second series, we thought to develop some efficient approach to get the molecules quickly and to get less data in comparison to linear scheme, because in linear scheme you need to take each step data to make those compounds. So we developed some divergent synthesis strategy. So for this, we try to make this intermediate 10, which is common intermediate, and for that we started with this piperazine substitution, followed by this again substitution, and then this substitution with aldehyde, and again novel condensation and reduction. And this substrate was synthesized on multi-gram scale because we need to make some library molecules. So we extended our work to demonstrate the scope of this 10 in alkylation by reductive amination using various aldehyde ketones in good yields. Though we can extend this further by Buchwald coupling and all that, CN coupling or other coupling as well. Now we try to explore the substrate scope by just reductive amination of some of aldehydes, and you can see there is these compounds are synthesized with good yield 63%, 51%, again 71, 67. So all these compounds are synthesized in good yield. So this methodology, all in all, we developed a versatile and efficient synthetic approach for synthesis of these compounds, and desired compounds were synthesized in good yields. And the major achievement is optimization of scalable process with good yield in each process, and the optimized reaction condition of this scaffold would be useful toward derivatization of scaffold to make promising molecule. Therefore, the substrate indeed gives us a chance for construction of competent organic molecules of medicinal importance. So another series of compounds basically for anti-cancer drugs that are based on some kinazole derivatives, and we utilize heterogeneous catalysis for Suzuki coupling, because in homogeneous coupling we need to reduce the palladium content to ppm level. I will discuss in subsequent slides. So let us have an overview of quinazoline derivatives as commercial drugs. If you can see, some compounds of this class are already have biological indication, and there are drugs in the market, for example, afinitive, giloritinib, geftinib. These are the drugs in the markets which are used for prostate cancer and all that, and degenerative disease as well. So looking at the literature, general strategy for synthesis of these quinazole derivative is generally by this DMF, DMA substitution and then dimer rearrangement. So let us have some light on the metal catalysts which are potential source of elemental impurities in drug production. So basically, as per ICH guidelines, every drug substance should have heavy metal within the safety limit prior to human trials, and palladium content specified by ICH is less than 10 ppm. So how to reduce these metal impurities, especially for homogeneous catalysis? We need extractions, crystallization, distillation, chromatography, and again this is a time consuming process, and there is maybe loss of compound during purification. And another approach is adsorption and complexation, metal scavengers. And metal scavenger, again we need to develop specific metal scavenger, and therefore we try to opt some heterogeneous catalysts. So we purchased this SilicaCat heterogeneous catalyst from Silicycle, and that is supported on silica matrix and immobilized by post modification of the inorganic support and with a high degree of leaching. So with SilicaCat, the ligand is directly cross-linked in an inorganic framework, resulting in a high degree of catalyst. Compared to homogeneous catalyst, celiac exhibit a good reactivity and selectivity, with one of the major advantages being that the catalyst is eliminated from the reaction mixture by a simple filtration. You can see if we take compound A and try to couple with compound B, then if we use celiac, we can have AB celiac in the reaction mixture, and we just filter that. Celiac can be recovered as a residue, and in the filtrate we get the pure compound. But no doubt limitation is that extra cost is required for synthesis of these catalysts. So first of all, to develop one-pot synthesis, we try to develop linear conditions which can be applicable to one-pot synthesis as well. So we tried this substitution in propane 2-ol, refluxing for 20 hours, which yields 80%, and then deprotection of this Bock, deprotection of Bock. Then again substitution, and finally Suzuki coupling with this celiac and different boric acids A, B, C, D is used to make these 5A2A. So we developed mild conditions for linear synthesis of quinazoline derivative, so that we can use them for one-pot synthesis. And with the optimal condition developed for linear synthesis, we explored the one-pot sequential synthetic methodology for these derivatives. So optimization of condition for SM coupling with this catalyst. If you see, we tried different molar percentage of the celiac catalyst, and in condition number 5, when we used 0.7 mole percent of this catalyst, then we got very good yield, around 98%. So we replicated this condition to couple 5 boric acids of different substituents. So moving on to our condition for one-pot synthesis. So basically we did one-pot synthesis. Reaction condition for one-pot synthesis with good yield were developed successfully, because we put this intermediate 1 with bocpiperazine. Then after 20 hours we put HCl in ethanol along with this piperidine dichloride, and followed by this Suzuki coupling after the reaction times, and we got these all molecules. And interestingly, the heavy metal analysis using ICP-MS is less than 10 ppm, which showed that palladium content of these compounds was within the acceptable limit as specified by the ICH guidelines. So if we compare the yields for stepwise and one-pot synthesis, you can see for compound 1, the yield for linear is 39% and one-pot is 69%.
Dr.
For
Vijay,
5B,
request you to expedite.
yeah. So you can see the overall yield is more than 68%. So finally, we developed an efficient method for one-pot synthesis, and catalyst use these heterogeneous catalyst which can be recovered, and this catalyst ensure minimum leaching for that. So we have reported an efficient versatile method, and 5 different boric acids was coupled to get the high yields. So therefore, this substrate indeed give a chance for construction of competent organic molecules of medicinal importance. So you can see the overall process for drug delivery. We need to design, make, then test, then understand. Again, this process goes, and then route scouting for a higher scale, and then lab scale. And so this is the part of medicinal chemistry, and this is the part of process chemistry. And I think controlled drug release can act as a breeze to reduce the to increase the success rate for drug discovery. So overall work I have presented is a combination of this medicinal chemistry and process chemistry, and controlled drug release is believed to be act as breeze in search of novel therapeutic drug. So these are acknowledgement. I would like to acknowledge Professor Sunita Ratan ma'am and Anup Bade from IVS, who is director in chemistry, and team at IVS. So thank you all for listening, and I will be happy to answer any questions.
Thank you, Dr. Vijay.
Yeah.
It was indeed a very nice lecture on medicinal chemistry, and it must be a very proud moment for most of the teachers here I mean, at least हमारे time पे तो ये होता था, हमारे department का student जाके is doing such wonderful work. It used to be a proud moment for us. And for all the students out there, something to look forward to. Anyways, so I'll request any questions from your end, if there are. I believe he has not shown the characterization. Probably he is not allowed to do so. Probably.
No, I can show characterization, but due to time constraints.
Okay.
There is a lot of things to tell because synthetic strategy, we have root scouting, different disconnection approach. I think in another form, yeah, we can explain all that data and all that.
Yeah, you had a lot of data.
Yeah, we have a lot of data, and yeah, this is the data, and this is in backup slides as well. I have just put one structure if you want to look at. There is NMR, HPLC, UPLC, and a lot of data we need.
Okay.
And some biological studies are going on and all that.
Okay.
That I
In
have
fact,
not
one of the slides remind me of an IIT JEE mains का paper. वो जो आपने third या fourth slide दिखाया था ना, Neumann reaction, ये वो.
Yeah.
It looked like an IIT JEE mains paper. You know, fill in the blanks. ये वाला compound is going to give you what?
This is what actually we do in the lab. Yeah.
Wonderful work.
Yes.
So if there aren't any questions, we would like to thank Dr. Vijay.
Yeah. Thank you.
Please. Yeah, big round of applause for him.
Thank you so much, sir, for your informative talk. Now we request Professor Sangeeta Tiwari ma'am and Dr. Prasoon Roy sir to present the memento to Dr. Vijay Kumar sir. We request Dr. Seema Garg ma'am to present the memento to Professor Sangeeta Tiwari ma'am. We request Dr. Seema Garg ma'am to present the memento to Dr. Prasoon Roy sir.
So now we are moving towards oral presentations. To encourage our research students and students from all over India, we have a session, I think, but the number of oral presentations are only 3. So we will start with the first presentation of Miss Isha Arora. She is from Amity Institute of Applied Sciences, and the topic of her presentation is fissile low temperature synthesis of bismuth, molybdate, stabilized ferricyanide and ferrocyanide nanocomposites. So Isha, please. And for please note that you have 8 minutes for presentation and 2 minutes for question answers. Okay. Sure. Presentation.
Okay. Good afternoon to one and all. Myself Isha Arora. I am pursuing PhD in chemistry in Amity Institute of Applied Sciences.
You just announce from there.
Okay, sure.
Just 1 minute.
Yeah.
Just wait for 1 minute.
Downstairs.
If he wants.
So we are going to start our oral presentation for the day 2 of our symposium, ETSC 2023. So this session will be assessed by Dr. Sangeeta Tiwari ma'am and Dr. Deepshika Gupta ma'am. Now we will be and Dr. Prasoon Roy sir. Now we will be proceeding with our oral presentation.
I'd like to invite Deepshika ma'am to the stage.
Now I would request Christine ma'am to please present the sapling.
I'm very proud to introduce our jury members to our audience. Professor Sangeeta Tiwari ma'am is Head Academic Coordinator of AIAS and Professor of Chemistry in Amity Institute of Applied Sciences. Dr. Tiwari holds a PhD in chemistry and she is highly accomplished researcher who has been conducting research and analysis for 20 plus years. Dr. Tiwari has made remarkable contributions to the field of chemistry, including over 40 plus publications in reputed journals. Dr. Deepshika Gupta ma'am is Associate Professor AIS and has a great research profile. She is also guiding many PhD candidates. She has several publications in reputed journals. Now we'd like to proceed with our online presentations.
पोस्टर के ना उसके respective LG.
May I request the participants of poster presentation to please go to their respective venues.
हो गया ना
दूसरी शीट में ये वाली इसकी दूसरी I'd like to introduce Ms. Isha Arora from Amity Institute of Applied Science to present her presentation.
Good afternoon to one and all. Basically, my research work includes synthesis and deep studies of bismuth-based nanoparticles, nanocrystals, for distinct environmental applications. So, I would like to talk about bismuth molybdate stabilized ferricyanide and ferrocyanide nanocomposites in this talk. Next slide, please. Okay, let's start with the basic mechanism first. When light strikes the semiconductor surface, electron excitation takes place. And what happens is, electron moves to the conduction band and holes are left behind in the valence band, as you can see here. Now, at the surface, at the conduction band, electron interacts with the surface oxygen and produces superoxide radicals. It is a basically reduction process. And here, holes interacts with the surface moisture and produces hydroxyl radicals. It is an oxidation process. So, all in all, redox reactions are taking place here, and these highly reactive radicals, superoxide radical and hydroxyl radical, they act on the target pollutant and degrade them. Okay. As per the literature review and all the experimental data, we know that conventionally used photocatalysts such as titanium dioxide, zinc oxide, they all possess high band gap and they are highly active under UV spectrum. So what we are doing here, we are trying to reduce the band gap. We want a material that is highly active under visible light spectrum so that we can make most of the sunlight use. So bismuth-based materials complete that space. They possess possibly less band gap and they have higher surface area. They have high electron mobility. They are very convenient for the whole photocatalysis process. So we are using these materials. Since there is an issue with this technique, the issue is the drawback is the recombination one. When light strikes the semiconductor surface, when electron moves to the conduction band, we highly want electron and hole to intact at the surface so they can interact with the surface oxygen and the moisture.
But what happens is they tend to recombine very fast. So it prevents the superoxide radical and hydroxyl radical production and redox reaction processes to move on. So we don't want that. Recombination should be as less as possible. So based on this, concerning this, we have chosen this material, bismuth molybdate, because in the literature review, this material have been shown to possess less photocatalytic activity. And this might be because due to the recombination between them. So we have chosen this material, modified it, and formed a nanocomposite with ferricyanide and ferrocyanide coordination complexes. We have evaluated band gap also, and if we compare these two materials, first one is for the ferricyanide one. It has got 2.95 electron volt, and second one is for the ferrocyanide one. It has got 2.78 electron volts, and this band gap is lesser, and it will be highly active under UV light because it is a criteria. As less is the band gap, it will be highly active under visible spectrum. So this is an advantage for us. We have for the successful incorporation of ferricyanide and ferrocyanide under the material, we have carried out the XRD. So we can see this sharp peak here. It confirms the presence, and all the several other peaks also, they have been in correspondence to the previous JCPDS card database, and they have confirmed the presence of bismuth molybdate orthorhombic phase in this material. And we have got three distinct peaks in this XRD, which are for potassium ferricyanide. We have compared that to the literature, and it has been confirmed that potassium ferricyanide has been incorporated within the material. And when you look at the second graph, it is for the bismuth molybdate ferrocyanide, and there is a very broad peak. This is very broad peak here. So we can say that it has not got the crystallinity. It is an amorphous sample. For further getting the crystallinity, we can further increase the temperature. Okay, for the recombination part, we have carried out photoluminescence spectra, which I was also mentioning earlier. This red peak is for ferrocyanide one, and it is of less intensity. So it shows that recombination is less in bismuth molybdate ferrocyanide as compared to the former one. These are the same images of both the samples, and we can see here that after the high magnification in both of the images, nanoparticles have been observed to form a cluster between them, and an average particle size of 141 nanometer and 100 nanometer for both of the samples have been observed. For the photocatalytic efficiency, we have carried out by the basis of methyl oil degradation, and these three plots are for the degradation plot. The third one you can see here, it compares the both of them. The red one is for ferrocyanide one. It shows that within 90 minutes of light irradiation, it has degraded 76% of the light, 76% of the dye. And this black one is for ferricyanide one. It has degraded 55% of the dye within 90 minutes. But we can say, but I can say that both of the samples have shown 1.5 times higher activity than the pristine bismuth molybdate. This plot is for the scavenging study, and it confirms that holes were highly responsible for the degradation of dye here. So we were successful in changing the pristine bismuth molybdate and promoting higher photocatalytic activity by adding making a nanocomposite with the coordination complexes. So lastly, I would like to acknowledge my guide, Professor Seema Garg, my co-guides, and my seniors for their constant support and guidance. Thank you so much.
Okay, if anybody wants to ask any questions, please. Yeah.
There's a slide of this band gap evolution.
Yes, sir. Yes, sir. We have evaluated by the proper calculation by the plotting a torque plot. Yeah, sir. There is a proper calculation for that.
Can you explain that?
Yes, ma'am. Yeah. God, God. Yeah. Ma'am, first one was we have plotted a talk plot in that, but second one was not possible. So Kubelka Munoika plot was we have plotted for that. Yeah. Yes, sir. I have. There's a separate complete calculation. That's yeah.
You have not shown values for pristine sample. You should have shown the comparison.
Yes, ma'am. I would have shown that because literature review we have done. So for that also.
And how it is, do you suggest any mechanism how that band gap is reducing?
Ma'am, actually, how band gap is reducing when we have incorporated ferricyanide, and so based on the whole mechanism that hypothetically we have thought of, the metal particles bismuth and molybdenum, both of them might have been added under the coordination sphere. So and by this I think it has enhanced the, because as per reported data also ferricyanide has been previously incorporated with titanium dioxide, so it has shown better activity. That's why we have thought of that to promote in this one.
But you should come up with some plausible mechanism that how it is reducing. Yeah?
Yes, ma'am.
Sir,
Yes,
you
we
want
are
to
doing
ask
that.
Deepshika ma'am, you want to ask? Yes.
Yes,
Yeah.
You have compared the XRD data of both the nanocomposite of ferri and
Yes,
ferrocyanide. I want to ask, why is there so much of difference in the crystalline structure of both? One is highly crystalline, the other one is very amorphous material. Any specific reason?
Ma'am, prior reason that I can think of, that is the temperature, but we have put the same temperature for both of the samples, so that I will think of why there's this much difference in crystallinity. Yeah, yes, ma'am. It might be due to the structure of ferri and ferrocyanide, but there is a very lot of difference. Yes, yes, ma'am. Sure. Thank you, sir.
Okay, thank you, Isha. Nice presentation.
So our next presenter is Mr. Abdul Rahman from Jamia Millia Islamia, Delhi.
Good afternoon, everyone. Myself, Abdul Rahman. I worked with Professor Nasimul Huda at Department of Chemistry, Jamia Millia Islamia. Today I am going to show my work title Design Synthesis and Pharmacological Evaluation of Oxospirochromen triazole based. Okay. Title. Okay. So that's it. Okay, 1 minute.
The previous slide.
Previous slides.
Can you change it on your? You're able to change.
Yeah, ma'am.
Okay, you start, please.
The title Design, Synthesis and Pharmacological Evolution of Oxospirochromen triazole based molecular hybrid as inhibitors of acetylcholinesterase for the treatment of Alzheimer's disease. Firstly, I would like to give some brief introduction on neurodegeneration. Neurodegeneration characterizes progressive and irreversible loss of and death of neurons in the brain. As a result of neuronal loss, it causes decline in cognitive functions, call it dementia. And there are thousands of neurodegenerative disorders. Some of them are Alzheimer's disease, Parkinson's disease, Huntington disease, and amyotrophic lateral. These are most prominent diseases. Coming to next slide, Alzheimer's disease. Alzheimer's disease is the most common form of dementia that usually starts at late middle age and old age. It causes decline in cognitive functions, language ability, recognition problem. About 3.6 lakhs of new cases of Alzheimer's disease are diagnosed each year. The main cause of Alzheimer's disease are not known, but several factors can be implicated. There are two main pathophysiology hallmark of AD. They are intraneuronal neurofibrillary tangle and extracellular deposition of beta amyloid plaques. Now, when we talk about structure-based drug design, we have to study the target enzyme thoroughly. For this, what we do, we have dogged or designed ligand with the target enzyme and found their binding affinity with the enzymes. And we have found that all the design molecule of a design molecule showed promising results, promising binding affinity with the target enzyme. Here, target enzyme is the human acetylcholinesterase. This is in this slide, I'm going to show you how our most promising design molecule interact with the target enzyme. Here we can see there is a pi stacking in the, I'm not saying, in the key residue, and there is a lot of interaction. There's a cation pi interaction, and there is a hydrogen bonding also. This is also hydrogen bonding. So we have found that our enzymes completely fit into the cavity of the target enzyme. So now from this data, we can proceed to further synthesize the molecule. Now coming to the synthetic part, here the target molecule can be synthesized. To synthesize the target molecule like this, we have started with orthohydroxyacetophenone and N-bok-piperidinone, followed by two consecutive reaction. We get the intermediate, this one. On the on the other hand, different substituted aniline converted into azides by well-known Sandman reaction. And lastly, we have reacted this intermediate and the formed azides to get this by well-known click reactions. These are my synthesized molecules. There are total 19 molecules. We are expecting to get the best results from this type of molecule, because these are already this is the coumarin based, and this is the dopamine, and this is the deoxyvaccination. So it has already anti-neurodegenerative property. And here in my work, I'm going to evaluate this bioactivity of this scaffold. Because this scaffold has anti-cancer activities, anti-diabetic activities, and also anti-malarial activities. Now we are and also anti-neuropathic pain also reported here. Okay. Now the synthesized molecules are characterized by proton NMR. This is the proton NMR of these compounds. Now coming to this compound, this compound has this 1, 2, 3, 4. This is here 4 aromatic proton, and this has 5 aromatic proton. So we have count them here. Already they are present in there 9 proton, and this proton has come to this downfield. And there are another 10 protons. The 2 protons for this. This 2 proton for this and 2 proton for this. This peak has, and this NMR validated our synthesis of the product. These are the carbon NMR and HRMS. The calculated mass of the product is 375.1816, and we have found 375.1815. So we have confirmed that our product has been formed. In conclusion, I would like to say that we have designed 19 small molecules, and their binding affinity with the human acetylcholine esterase has been checked through molecular dialing using Schrodinger software, and we have. Sorry. Excuse me. Okay. Thank you. And I would like to say that we have successfully synthesized the 19 molecules, and they are characterized by using carbon 13, proton NMR, and mass spectrometry. And their biological activity is ongoing, and we are going their biological activity against three biological targets: that is human acetylcholine esterase, misfolded protein aggregation of amyloid beta 42, and tau oligomerization is going on. Finally, I would like to thank Professor Nasimul Hoda, my guide, and our HOD ma'am, and all teachers, staffs in my and lab mates in my college. And finally, I would like to thank University Grant Commission for financial support. Thank you.
Thank you, Mr. Abdul Rahman.
Yes.
If anybody has any question, you may please ask. Deepshika ma'am.
Can you show the synthetic scheme? That
Yeah,
slide. Yes. So what are the series of reactions which you have used to convert the salicylaldehyde molecule to the spiro molecule? The series, you said many steps.
Yeah, basically, second, yeah. Ma'am, first, here is.
It's a one-pot synthesis.
No, ma'am. It is a three-step process. No one-pot synthesis. The final step is one-pot. This one, no one-pot, not.
So what are the steps involved?
Okay. Here, first step involves in aldol reactions, followed by deprotection of the nitrogen group, and then propagylation of the nitrogen group. We get final intermediate, this one.
Spiro group is coming from the aldol condensation.
Yeah, ma'am. Basically, aldol condensation. I'm not showing the conditions here because these are unpublished work of me.
How did you test the activity?
Activity, we have collaborators, ma'am. They are doing their part. We are on a synthetic chemist.
You are only doing the synthesis. Okay. Who are your collaborators?
We have collaborators in the University of Cornell, Mustafa Gabbar.
University of?
Cornell.
Okay.
Cornell.
This is outside India?
Yeah, USA.
Okay. So how you're doing that? Sending your samples?
Yeah.
Okay, good. Okay, any questions from audience? Okay, no, thank you. There are no questions. So thank you very much. Can we have the third presentation, please?
So our last presenter for the day is Mr. Nazim Ali.
Good afternoon, everybody. Myself, Nazim Ali. I'm pursuing PhD from MIT University under the guidance of Dr. Sunita Radhan, ma'am.
Please also tell about your affiliation. You are doing part-time from...
Yes, yeah.
So where you are working?
I'm part-time PhD in chemistry, and I'm working in Jubilant Biosys Limited as a research scientist. I have around 9 years of experience in that company. And first of all, I want to thank the organizer for giving me an opportunity to present my work here. So thank you. Okay. So for today presentation, my topic is synthesis of nitrogen substitutes, benzyl imidazole derivatives and their applications. So benzimidazoles are very, they have very much importance in pharmacological field. They have so many medicinal activities. So I have selected, that's why benzimidazole. And for my synthesis, I have selected two benzyl benzimidazoles because there is, I got not many reported literature there. Means very less work done there on two benzyl benzimidazoles. Maximum work I found this phenyl benzimidazole synthesis. That's why I have selected this moiety, two benzyl benzimidazoles. And benzimidazoles having these many activities like anti-allergic, anti-tumor, antihistamines, anti-malarial, antifungal, so many activities. So owing to the importance of this, means we will synthesize some derivative, nitrogen substitute derivatives we will synthesize, and then we will do some medical activity. So far I have synthesized this core intermediate, like we can say this is starting material for my research work. So with this diamine and phenylacetic acid, simple in acidic medium on heating it is getting cyclized. So two conditions I have tried, like SCl and one is POCl3. So in POCl3 in last time we are getting more yield. That's why we have selected POCl3 condition. And after this we have synthesized four compounds. So like compound 1, compound 2, compound 3, and another is next one. And these compounds we have confirmed with 1H NMR and LCMS so far, like C13 and HRMS given. So they are awaited so far. And one compound's analytical data I have pasted here. This is 1H NMR. So we have confirmed on the basis of 1H NMR that our compound is correct. All the signals according to the structures very much visible, and the pattern also indicate that our compound is correct. And this one LCMS, liquid chromatography mass spectroscopy. So in this the purity is also good, and the mass is coming. Our compound mass is 294, and it is positive mode, it is coming 295. That's why mass also good. So compound is according to 1H NMR and LCMS, compound is okay. And this one is fourth compounds. So this is melamide type derivatives. So in first fourth column, this is general structures, and in fifth column this is compound number 4. So according to this, like N-ethyl, so we will synthesize like N-methyl, N-phenyl, like these derivatives. Then we will do some activity. And this one more derivatization. This is like ataconic anhydride. So this double bond compounds intermediate force we will make with amine ataconic anhydride in acidic medium. It is giving desired compound. So like compound number 3 we will get most probably according to our previous compounds, same compound number 3 we will get. And on the basis of what the results we will get from our synthesized compounds, so we will select another benzimidazole moiety, like we will introduce one keto in between, and one more carbon we will increase the compound B. Then we will synthesize derivatives, nitrogen substitute derivatives, and then we will do some biological activity. So these are some references. Thank you. Only this one. Some questions.
Any questions, please? Actually, presentation was not clear. Even we were not able to see the results. I don't know what.
In results, so for synthesis work, we have
graphs were not clear, and
these compounds, like synthesis of these compounds, we have done only. No biological activity so far.
Okay.
So we are making the compounds first, then around 10-15 compounds we will make, then we will perform an biological activity.
Can you explain the novelty of your work here?
In this compounds, whatever literature I got, they have derivation done on this benzyl ring. So nitrogen substitute compounds very few compounds I found. So these type of compounds.
Very few means there are.
They are, but
Some.
very few. But they are making those compounds with like halogen or with base. So these are like simple double bonds and free NH. So means without any base, we are making this compound.
So what is the basis of your doing this? Means why you are choosing? What gaps have you identified, and what you are going to do in your work? What new you are going to do in your work?
This compounds having very much nice biological activities. So on these compounds, one more carbon is there. So this compounds are not very biological activity, very less activity are reported on the benzyl substitute compounds. There NH substitute compounds. So far, study not done, according to my literature review.
The extra the CH2 group which you are introducing here, the conjugation between the two rings has stopped. So you think that introduction of one more carbon atom, it is going to help you out in enhancing the activities of benzimidazoles?
That one we'll see what the result we will get.
What type of activities are you targeting?
First, we are thinking like anti-allergic activity. First, we will try.
They show mostly anti-bacterial, anti-fungal activities.
Yes.
So you are anti-allergic. You are targeting on what basis?
It's on this compounds like anti-allergic, anti-tuberculosis, anti-cancer, anti-HIV activities are reported. So on the basis of these compounds, we will see like introduction of one more carbon is there. So it will help to increase any activity or not.
So whatever activity you are proposing, accordingly you can select a target protein. You can carry out the biological activities beforehand through tools and all, and you have to propose which type of functional group will help you out to enhance the activity. That type of functional groups, if you introduce in your molecule, it will help you out. Instead, making all the series and then doing the activity.
Okay.
That should not be done that way. Instead, you should first propose what type of functional groups would be better, what type of activity you are looking for.
Yes.
Design your work and accordingly synthesize the molecules.
So now first like 4 compounds. So we will try with 4 compounds. Then we will check.
So okay, thank you so much.
Thank you.
It was a nice presentation. I don't think all participants have done. No? Results declare. You want to declare it right now? So we have to wait for it. Or again announced and schedule session. Now
Everyone, there will be a valedictory session after 15 minutes. So there will be a break for 15 minutes. Then please join us in C Block Auditorium. Thank you.